What if the oldest pyramid on Earth is not in Egypt at all, but hidden deep beneath the rainforests of Indonesia? What if it was built almost 28,000 years before the first pharaoh was even born, by people whose names and stories have faded into legend? In today's video, we'll take a journey deep into humanity's forgotten past, a journey that forces us to question what early humans were capable of, how they understood their environment, and whether knowledge rises and falls in repeating cycles, just like civilizations themselves. Before we go deeper into this ancient mystery together, take a moment and let us know in the comments below where in the world you're watching from, and if you're ready for the voyage, hitting that like button and subscribing tells me you're on board. In the early morning mist of West Java, where ancient volcanoes rise on the horizon like silent sleeping giants, a place called Gunung Padang, meaning mountain of light, slowly emerges from the bright green rice fields. At first glance it looks simple and unremarkable, but beneath the surface something far more astonishing may be waiting. Around 28,000 years ago, during the coldest part of the last ice age, enormous ice sheets spread across the northern half of the world. So much water was trapped in frozen towers of ice that sea levels fell dramatically, and the ocean pulled back to reveal something extraordinary. What is now hidden beneath the sea was once a single immense landmass, larger than modern India, joining today's scattered islands of Southeast Asia into one continuous continent. This lost world is known as Sunderland, and it may have been one of humanity's earliest great centres of civilization, perhaps even the birthplace of a powerful maritime culture. Today, its remains lie buried beneath more than 400 feet of water. Modern seafloor maps show that this sunken land was not flat or lifeless. Instead, it was a gently rolling landscape, shaped by hills, valleys, and enormous river systems. These rivers once carried meltwater from distant mountains across hundreds of miles of open land before finally reaching the sea. The Mekong River, which today empties into the South China Sea, once flowed across a vast exposed plain, winding its way toward the ancient coastline near what we now call Borneo. The great rivers of Sumatra, Java, and Borneo joined together in enormous deltas, creating rich wetlands and grasslands filled with life. These lands were home to creatures that no longer exist, giant relatives of orangutans, enormous pangolins, and cave bears as large as small elephants. They roamed warm plains that never knew winter, under skies untouched by ice or snow. This raises a haunting question. What traces of early human life lie hidden beneath these drowned river valleys? Throughout history, every major early civilization we know grew along rivers. The Nile, the Euphrates, the Indus, and the Yellow River all nurtured complex societies. Yet the river systems of Sunderland were even larger, flowing through lands rich in obsidian from volcanoes, perfect for making razor-sharp tools. Gold and copper were scattered through riverbeds, ready for early metalworking. Wild ancestors of rice, bananas, and other vital crops grew naturally in this fertile environment, offering food security long before organised farming as we understand it today. If the builders of Gunung Padang truly shaped stone 28,000 years ago, they were not working on a small isolated island. They were part of a continent-sized world perfectly suited for the rise of complex society. To the east, the Sahel Shelf tells a similar story. It once connected New Guinea and Australia into a single land, long before rising seas pulled them apart. Aboriginal, Australian, and Papuan oral traditions still speak of a time when people could walk between lands that are now separated by water. They tell of hunting grounds that lie beneath coral reefs today, and sacred places swallowed by the sea. Modern genetic research supports these stories, showing that the ancestors of Aboriginal Australians and Melanesian peoples once shared the same lands, the same paths, and the same sacred landscapes. Long after the ocean reclaimed the land, these memories survived in story and song. Here lies the great tragedy for archaeology. For roughly 20,000 years, rising seas have hidden or destroyed the coastal settlements where early civilizations were most likely to thrive. Harbours, river mouths, and narrow peninsulas where ancient builders would have chosen to live and build now rest beneath thick layers of sand and mud. Reaching them requires the most advanced underwater technology we possess. Yet even with limited access, we have seen hints of what may lie below. Geometric stone formations near Japan's Yonaguni Island and aligned megaliths scattered along Indonesia's coast suggest ancient building traditions far older than we once believed. They whisper of a time when these stones were not coastal mysteries but inland monuments. What if the remarkable precision found in the deepest layers of Gunung Padang is not the work of a single isolated site, but part of a shared architectural language? When we look at Indonesia's many megalithic locations, Gunung Padang, the Posema Plateau, Nias Island, and ancient stone villages, strange patterns begin to appear. Their measurements, orientations, and designs might make perfect sense if we imagine them as connected points across a once unified land. They may have served as landmarks or navigational beacons across a continent that no longer exists, guiding travellers across territories now split by hundreds of miles of open ocean. Sunderland occupied one of the most powerful positions on Earth for the rise of advanced seafaring culture. Picture it as the meeting point of three great worlds. Asia stretched north into cooler climates. Australia extended south into entirely different seasons. To the east lay the vast Pacific, opening pathways toward lands far beyond the horizon. Ocean currents, monsoon winds, and predictable seasonal shifts turned this region into a natural classroom for mastering navigation. Generations of people would have learned to read the stars, the winds, and the waves with a precision unmatched anywhere else. The environment itself seemed almost perfectly balanced for early human development. While much of the northern world struggled through brutal Ice Age conditions, surviving on frozen plains and hiding in caves from deadly winds, Sunderland enjoyed relatively stable tropical and subtropical climates. Ironically, the same ice sheets that caused global hardship also protected this region from extreme climate swings. Volcanic activity, though sometimes destructive, provided obsidian sharper than modern surgical tools, pumice for construction, and rich soils capable of supporting large populations without advanced farming systems. Living along the Pacific Ring of Fire meant constant interaction with powerful geological forces. Over time, this may have taught Sunderland's inhabitants deep knowledge of earthquakes, volcanoes, and the hidden rules of stone and structure. Such understanding would be essential for building monuments meant to endure for thousands of years. Resources were abundant. Gold and copper lay in river deposits where they could be collected by hand. Vast hardwood forests supplied timber for shipbuilding on a scale that would challenge even modern industry. Bamboo, growing to full size in a single season, offered instant materials for scaffolding, tools, and construction. The region's astonishing biodiversity provided endless natural examples of efficient design, from the perfect geometry of honeycombs to the strength of tree roots and the sound-carrying shapes of shells. Above all else, Sunderland was defined by its bond with the sea. This was not a landlocked civilization separated from the ocean, but a world where land and water blended together. Thousands of miles of coastline, river estuaries, and inland waterways formed a natural network of travel and trade. In such a place, the line between land and sea disappeared, and humanity may have taken its earliest steps toward becoming a truly ocean-going species. The yearly monsoon, with its steady and predictable change of winds and rains, acted like a living classroom for ancient people. By watching it closely, they learned how the world truly worked on a large scale. They began to understand repeating weather patterns, the movements of the stars and planets, and the deep connection between what happens in the sky and what unfolds on the earth. Life under the monsoon taught patience, observation, and long memory. It trained people to think in cycles rather than moments, in seasons rather than days. To travel across the immense distances of the Sunda landmass and the surrounding seas, people had to master skills that were anything but simple. They learned how to read the long rolling shapes of ocean swells, how to feel subtle changes in the wind, and how to track the seasonal movement of stars as they rose and set in different parts of the sky. They noticed small signs in cloud shapes, and bird behaviour that quietly hinted at land far beyond the visible horizon. These abilities were not primitive instincts, they were advanced mental achievements, equal in complexity to raising massive stone monuments. When seen this way, the idea that the builders of Gunung Padang could align stones with the heavens 28,000 years ago no longer seems mysterious. With this level of knowledge, such precision would have been a natural outcome. Even today, fragments of this ancient wisdom still survive among indigenous cultures across modern Indonesia. The seafaring Buddhist navigators of Sulawesi continue to use star compass systems that divide the horizon into carefully organized geometric sections. Traditional Balinese calendars combine the movements of the sun, the moon, and the stars into farming and ceremonial schedules of remarkable mathematical depth. Communities within Dayak cultures preserve oral stories that describe river networks and land boundaries with astonishing accuracy, matching the shape of the long-lost Sunda shelf as it existed when it was dry land. It is as if detailed mental maps were passed down across 20,000 years of shared memory. All of this points to a civilization uniquely prepared to develop both the practical knowledge needed to build great structures and the deeper philosophical insight to unite astronomy, spirituality, environmental awareness, and technology into a single worldview. Sunda was not simply a place where civilization happened. It was a vast learning system that trained its people to think across enormous stretches of time and space all at once. Then, sometime around 19,000 years ago, the world began to change in a way humanity had never faced before. The massive ice sheets that had locked up the planet's water started to melt. What followed was humanity's first truly global disaster, the return of the seas. Around 14,600 years ago, a dramatic event known to scientists as Meltwater Pulse 1a caused sea levels to rise by more than 40 feet in only a few centuries. In geological terms, this happened in the blink of an eye. To the people living through it, it would have felt like the end of the world. Shorelines crept inland fast enough to be noticed within a single lifetime. Villages, fields, and sacred places vanished generation by generation, forcing entire populations to flee toward higher ground. The emotional shock of this rapid change cannot be overstated. Societies that had spent thousands of years developing coastal towns, safe harbours, and complex sea trade networks suddenly saw their entire way of life swallowed by the ocean. River mouths that had served as natural ports for countless generations disappeared beneath the waves. Wide coastal plains that once supported dense populations turned into shallow seas. Landscapes that shaped identity, belief systems, and technological progress were erased season after season, leaving behind loss, confusion, and urgency. Evidence from archaeology suggests that people did not slowly adapt to this rising water. Instead, they were violently displaced. Genetic studies point to sudden population movements during this period, showing maritime peoples spreading rapidly across the Pacific. They carried with them their traditions, their navigation skills, and perhaps even their knowledge of stone building developed when Sunda was still whole. The striking similarities between massive stone structures found from Indonesia to Easter Island, from Madagascar to the Americas, may not be coincidence. They may reflect the scattering of a single advanced building tradition carried by refugees escaping a sinking continent. The deepest layers of Gunung Padang would have been built during the early stages of this unfolding catastrophe. If the dating of 28,000 years is correct, these builders lived at the height of the last ice age, when sea levels were at their lowest and Sunda reached its greatest size. Through careful observation of ice behaviour, attention to the stars, or wisdom passed down from earlier climate shifts, they may have known that the waters would one day return. This awareness could explain one of Gunung Padang's greatest mysteries. Why construct such a massive stone complex only to bury it beneath layers of earth and later building phases? If the builders expected a coming disaster, the site begins to look less like a temple of power and more like a vault of memory, designed to protect knowledge through the destruction of their world. The forced migrations caused by rising seas shaped the path of human expansion that still continues today. Coastal peoples driven from their homelands became daring explorers, spreading across the oceans with unmatched skill. The Austronesian expansion, which scholars date to around 3,000 years ago, may have been only the latest chapter in a much older story that began 15,000 years earlier with the flooding of Sunda. Flood stories preserved across the Indonesian islands contain strikingly specific details from this time. Javanese legends speak of lost kingdoms beneath the Java Sea. Oral histories describe a great scattering of people to high mountains and distant islands. These stories are not vague myths. They include real locations, navigation routes, and seasonal clues that align closely with geological and archaeological evidence of rising seas after the Ice Age. This raises a powerful question. What if what we call the birth of civilization was actually its rebirth? What if the advanced stone sites around the world, the possible greater age of the Sphinx, and the precise astronomical alignments of megalithic observatories are echoes of a recovery period following humanity's first great collapse. An earlier advanced civilization may have drowned beneath nearly 400 feet of rising ocean, taking much of its knowledge with it. Today, standing on the terraced slopes of Gunung Padang and gazing across the Java Sea toward horizons that were once dry land connecting Indonesia to Malaysia, we are faced with a humbling reality. Entire continents of human achievement have vanished beneath the waves. Along with them disappeared hard-earned wisdom about living on a planet shaped by repeating cycles of ice and warmth that stretch far beyond the lifespan of any single culture. In the year 2010, Indonesian geologist Dr. Danny Hilman Natawijaja walked toward what looked like an ordinary grassy hill in West Java. He carried instruments that could read the earth like an ancient manuscript: ground-penetrating radar, electrical sensors, and seismic tools that listened to the planet's deepest whispers. What these machines revealed would shake the foundations of archaeology and continue to echo through scientific debate to this day. Gunung Padang had been known for generations by local people as a place filled with unseen power and deep meaning. Long before scientists arrived with machines and theories, villagers spoke of it as a sacred hill, a place where the ground itself seemed alive. Its sloping terraces, scattered with tall ancient stones, were comfortably explained by traditional archaeology as being from Indonesia's classical past, perhaps around 2,000 years old. To most experts, the stones were impressive but familiar, fitting neatly into accepted ideas about when large stone structures could be built. But when Danny Hilman Natawijaja came to Gunung Padang, he did not see it only through the narrow lens of archaeology. His training was in geology, a science that deals with immense stretches of time, the slow rising of mountains and the shifting of continents over millions of years. Where archaeologists saw scattered remains left behind by known civilizations, he sensed something deeper and far older. To him, the hill did not look like a natural formation decorated with stones. It looked like a structure, carefully shaped over ages, hiding a story that did not fit the accepted timeline of human history. When ground-penetrating radar was first used at the site, the results were shocking. Beneath the visible stone terraces lay formations that did not resemble random rock or natural layers of earth. Instead, they appeared carefully organized, stretching deep into the heart of the hill. There were layers of worked stone stacked one upon another, arranged in complex geometric patterns. These layers seemed to be connected by intentional passageways and chamber-like spaces, suggesting planning, design, and purpose. The deeper the scans went, the clearer it became that this was not a single construction, but many. The electromagnetic signals pointed to several building phases, each separated by vast stretches of time, and each more advanced than what mainstream theory believed possible for such ancient periods. The real shock came with the carbon dating. Samples of organic material trapped between the stone layers were carefully collected. Charcoal, fragments of ancient wood, and soil sealed within the construction were tested. The results sent tremors through the academic world. The deeper samples taken from drill cores that reached the foundation of the hill returned dates between 25,000 and 28,000 years before the present. These dates placed advanced stone construction deep in the last ice age, a time when most textbooks describe humans as small groups of struggling hunter-gatherers, barely surviving brutal climates, not organizing large construction projects of stone and geometry that rival famous monuments of recorded history. Predictably, resistance came fast and fiercely. Established institutions built upon carefully arranged timelines of human progress could not easily accept such a challenge. According to conventional archaeology, complex construction should not exist tens of thousands of years before agriculture, cities, or organized states. Critics raised familiar objections. They claimed the samples must be contaminated. They argued that natural geological processes were being misunderstood. They insisted that complex societies could not exist before what is called the Neolithic Revolution. Yet with each attempt to dismiss the findings, further studies were carried out using even more advanced tools, and instead of weakening the case, the evidence grew stronger. What truly unsettles scholars about Gunung Padang is not only how old it might be, but what it suggests about human potential. If modern humans were capable of organising large construction efforts 28,000 years ago, then our understanding of prehistory may be deeply flawed. The idea that human progress followed a simple straight line from primitive to advanced begins to crumble. Instead, Gunung Padang hints at a far more complex story, one filled with forgotten chapters and lost achievements. This possibility becomes even more intriguing when viewed in a broader context. Genetic research shows that modern humans reached Southeast Asia at least 73,000 years ago. They survived the catastrophic Toba supervolcanic eruption, an event so powerful it may have reduced the global human population to fewer than 10,000 individuals. Those who lived through such a disaster would have needed extraordinary adaptability, deep environmental knowledge, and perhaps advanced technologies born out of necessity. Between the Toba eruption and the earliest possible construction phases at Gunung Padang lies a span of roughly 45,000 years. That is more than enough time for complex cultures, advanced understanding of the sky, and sophisticated engineering skills to develop, flourish, and even be lost. Still, acceptance remains difficult. Entire academic careers, funding systems, textbooks, and university departments are built upon specific ideas of how and when civilization began. To admit the existence of monumental architecture nearly 30,000 years old would require rewriting not just the history of Indonesia, but the story of humanity itself. It would mean acknowledging that humans may have mastered architecture, astronomy, and large-scale cooperation long before they are supposed to have learned how to farm or domesticate animals. Despite isolation and limited support, Dr. Natawijaya continues his work. He is driven by the belief that some truths are too important to ignore, even when they cause discomfort. His team patiently gathers data through geological surveys, electromagnetic studies, and careful analysis of soil and stone layers. Step by step, they are building a case that asks us to rethink what humans were capable of across vast stretches of time that make individual ambition and academic politics seem small. One of the most fascinating ideas to emerge is that Gunung Padang may not be a single monument at all, but a layered record of human achievement. Like a manuscript written over again and again, each generation added to the site, building upon the knowledge of those who came before. Stratigraphic studies reveal 5 distinct construction phases, each separated by thousands of years. This suggests that the site was not continuously occupied, but repeatedly returned to, always remembered as sacred across countless generations. The uppermost layer, the one most familiar to archaeologists, dates to between 2,000 and 4,000 years ago. This is where the visible stone terraces stand today. Here we see tall andesite columns cut with precision and arranged in careful geometric patterns. There are fitted stone walls and ceremonial platforms that reveal a strong understanding of structure, balance, and alignment with the heavens. This phase clearly connects Gunung Padang to other well-known megalithic traditions across Indonesia, from stone calendars in central Java to ancestor statues on Sumba Island. Yet even this relatively recent layer raises questions. Some of the stone columns weigh several tons each. They were quarried from distant andesite outcrops and somehow transported uphill using methods that remain unknown. Laser measurements show that their placement achieves levels of precision that would challenge even modern builders. Perhaps most intriguing of all, the arrangement of stones creates unusual acoustic effects. Certain spaces amplify the human voice at specific frequencies, forming natural resonance chambers. This suggests the builders understood principles of sound and vibration that modern science has only begun to rediscover at ancient sites around the world. Beneath the surface layer that can be seen today, ground-penetrating radar paints a far more astonishing picture. It reveals a second stage of construction dating back between 8,000 and 10,000 years ago, during the early Holocene period, a time when rising seas were dramatically reshaping the Indonesian landscape. This hidden layer shows engineering that is even more advanced than what lies above it. The stones are larger, the layouts follow more complex geometric patterns, and there are clear signs of a carefully planned water system. Mountain springs appear to have been guided through precisely carved stone channels, allowing water to flow in a controlled and deliberate way. These designs suggest builders who deeply understood how water behaves, how stone and earth remain stable over time, and how to plan structures meant to last for generations, on a scale that would challenge many modern projects. Deeper still lies a third layer, dating back roughly between 15,000 and 20,000 years ago, during the late Pleistocene. This was a period when rising seas were beginning to swallow the coastal lands of Sunderland. At this depth, the radar data becomes truly astonishing. It shows massive stone columns arranged in perfect geometric relationships, large internal chambers, and what looks like a sophisticated foundation system anchored deep into the hill's bedrock. The sheer size of this construction points not only to advanced technical skill, but also to a highly organised society capable of coordinating large numbers of people over many generations to complete such an immense project. Then comes the fourth layer, dating to between 20,000 and 25,000 years ago, formed during the last glacial maximum. This is where long-held beliefs about human limits during the Ice Age begin to collapse. At this time, global sea levels were at their lowest, and Sunderland stretched across its greatest extent. The electromagnetic signals from this layer suggest construction on a monumental scale. Vast underground chambers, carefully engineered stone foundations, and architectural layouts that appear to align geological features with astronomical observations all point to a sophisticated understanding of both the heavens and the earth. These builders were not simply stacking stones, they were integrating science, nature, and long-term planning into a unified design. Yet the deepest and most mysterious layer of all dates back between 25,000 and 28,000 years ago, near the peak of the last glacial maximum. According to conventional archaeology, this was a time when humans lived in small nomadic groups focused mainly on survival. But the radar and seismic evidence tells a completely different story. This earliest phase appears to surpass all later construction stages in both size and complexity. Enormous shaped stone foundations, intricate chamber networks, and precise architectural relationships suggest advanced mathematics, detailed astronomical knowledge, and engineering skills that even today would be difficult to replicate. This layer represents one of the greatest unsolved mysteries in human prehistory. What emerges from this layered analysis is not the familiar story of slow, steady progress, from primitive beginnings to modern sophistication. Instead, it reveals a far more complex pattern that unfolds over nearly 30,000 years. It shows cycles of great achievement, abandonment, and rediscovery. Each new phase builds upon the knowledge of the one before it, adapting to changing climates and landscapes rather than simply improving upon earlier designs. The earliest builders created foundations so advanced that later societies, despite their own impressive abilities, chose to build on top of them rather than replace them. The implications reach far beyond a single site in Indonesia. If humans were capable of such extraordinary construction 28,000 years ago, how many other achievements might be buried beneath our assumptions about prehistoric life? The pattern seen at Gunung Padang, early brilliance followed by long periods of loss and gradual rediscovery, may reflect human history far more accurately than the simple linear models taught today. It suggests that human capability is deeply connected to environmental conditions. The most advanced phases appear during times of stability and wide territorial reach, while later phases show adaptation rather than true advancement. It is as though the earliest builders possessed knowledge that later generations preserved but could not fully recreate, adjusting ancient wisdom to new circumstances across immense spans of geological and climatic change. To design structures meant to survive not just centuries, but tens of thousands of years of earthquakes, volcanic activity, erosion, and shifting climates would require an extraordinary level of understanding. Engineering studies of Gunung Padang reveal techniques we normally associate with modern science. These include careful evaluation of geological stability, resistance to earthquakes, precision stone shaping, acoustic design, and hydraulic systems that guide water with mathematical accuracy. The placement of stone columns alone is baffling. Laser measurements show that massive andesite pillars, some weighing several tons, are positioned with tolerances measured in millimeters rather than centimeters. This precision applies not only to individual stones, but also to their geometric relationships across distances of hundreds of meters. Even more astonishing is that some of these alignments correspond to astronomical events with remarkable accuracy. Achieving this would require advanced surveying methods and a deep understanding of how stars and celestial positions slowly change over time due to the Earth's axial precession. The builders also demonstrated remarkable insight into geological stability. Constructing on the slopes of an active volcanic region demands strategies to handle earthquakes, ground movement, and relentless tropical weathering. Core samples show that the stones were not simply placed on the surface. Instead, deep foundation systems were carved into the bedrock itself, carefully distributing weight through a complex interaction between worked stone and natural geology. This is the same kind of thinking behind modern earthquake-resistant design, applied tens of thousands of years before such knowledge was thought to exist. The internal chamber systems are just as impressive. Subsurface imaging reveals large man-made cavities connected by deliberate passageways. These chambers remain structurally sound despite the enormous weight of earth and stone above them, indicating a sophisticated grasp of load distribution, arch-like construction principles, and possibly even early reinforcement techniques. Perhaps most intriguing of all are the acoustic properties found within the structures. Detailed studies show that the stone arrangements form resonance chambers that amplify certain ranges of the human voice while muting others. This effect is far too precise to be accidental, hinting that sound itself may have played an important role in how these ancient spaces were designed and used. The way the stones were placed, the carefully measured gaps between the massive blocks, and the way different groups of stones relate to one another were not done by chance. All of these choices work together to create deliberate sound effects. When people stand or speak in certain areas, sound behaves in unusual ways, echoing, amplifying, or focusing as if the site itself were designed to listen and respond. Similar sound-shaping designs have been found at ancient stone sites around the world, from Stonehenge in England to the underground chambers of Malta. This strongly suggests that ancient builders had a deep and practical understanding of how sound moves, how it affects the human mind, and how it could be used during rituals, ceremonies, and altered states of awareness. Perhaps even more impressive is the water management system hidden within the site. Modern electromagnetic surveys have revealed wide networks of stone-lined channels, drainage paths, and what appear to be underground water storage spaces. These systems were designed to capture natural springs and seasonal rain, and guide the water through carefully shaped stone passages. The result was a steady and controlled flow of water that prevented erosion, protected the structure, and adapted smoothly to changing seasons year after year. The precision of these water systems shows a clear understanding of how water behaves underground, how it interacts with rock and soil, and how such systems must be maintained over very long periods of time. The level of skill involved rivals what we expect from modern civil engineering, even though it was achieved without modern machinery. The quality of stone craftsmanship across all stages of construction raises even more difficult questions. The builders worked extensively with andesite volcanic rock, a material known for being extremely hard and difficult to shape. Cutting, smoothing, and fitting. This stone with the level of accuracy seen at the site would have required remarkable skill and advanced techniques. Yet there is no clear evidence of metal tools capable of producing such results. This leaves us with a mystery. Either these builders possess technologies we do not yet understand, or they use stoneworking methods that have been completely forgotten over time. What truly sets the site apart, however, is how all of these systems were combined into one unified design. The builders of Gunung Padang did not simply master stone cutting, sound control, water engineering, or structural stability on their own. They brought all of these skills together into a single architectural vision. The structures appear to have functioned at the same time as astronomical observation points, ceremonial gathering spaces, and possibly even as repositories for preserving knowledge across vast spans of time. This level of planning shows systems thinking and project management abilities that we usually associate with the most advanced civilizations in recorded history. Yet according to conventional archaeology, these builders lived during periods when humans were supposedly organized only in small, simple, and technologically limited groups. Detailed engineering analysis makes one thing clear. The builders of Gunung Padang did not just possess advanced individual skills, they understood how different technologies could support and strengthen one another to create structures meant to endure across geological timescales. They were not building only for their own generation. They were building for a distant future they might never witness, embedding their knowledge into stone patterns that could continue to teach anyone capable of understanding their architectural language. This leads to a profound question. What kind of mindset drives a civilization to hide its greatest achievements? Why would builders deliberately bury monumental structures beneath layers of earth and later construction? The evidence at Gunung Padang points not to accidental burial caused by nature, but to intentional camouflage. Over time, the site was carefully transformed from an obvious monument into a hill that appears completely natural, and this deliberate concealment may be the most fascinating aspect of the entire complex. The builders were skilled enough to create structures that rival anything in human history, yet wise enough to make those structures invisible to casual observers. Stratigraphic studies show clear signs of intentional burial across multiple building phases. Between major construction periods, thick layers of soil, smaller stones, and organic material were placed over earlier structures. These layers protected what lay beneath, while also creating stable foundations for later additions. This was not the slow build-up of dirt over abandoned ruins. The patterns, materials, and careful placement reveal long-term planning and a massive investment of labour. The camouflage itself was highly sophisticated. Instead of simply dumping earth over stone structures, the builders designed layers that closely matched natural geological processes. The soil resembles local earth. The stones follow patterns consistent with natural erosion and deposition. Organic materials were spread in ways that encouraged plant growth, allowing vegetation to take over and complete the illusion. Over time, the monument became a living landscape, indistinguishable from a naturally formed hill unless examined with advanced scientific methods. Similar examples of monuments hidden in plain sight can be found around the world, hinting at a shared ancient wisdom focused on protecting sacred knowledge. Gunung Padang may not be an isolated mystery, but part of a much older tradition that valued preservation, patience, and foresight above visibility and recognition. Göbekli Tepe in modern Turkey offers one of the clearest clues that ancient people sometimes chose to hide their greatest works instead of showing them off. Around 8,000 years before the Common Era, this extraordinary place was carefully and deliberately buried beneath enormous amounts of soil and stone. This was not destruction or abandonment, it was preservation. By sealing the massive stone circles underground, the builders protected their carvings and structures from weather, human interference, and the slow, grinding damage of time, allowing them to survive almost perfectly until they were rediscovered in the modern age. A similar story can be seen in Egypt, where the Great Sphinx shows clear signs of being buried by sand and then dug out again many times across history, as if it repeatedly vanished and reappeared with the passing of civilizations. In the Amazon rainforest, vast stone structures remained invisible for centuries, hidden beneath thick forest canopies, only becoming visible now through advanced light detection and ranging technology that can see through trees. In North America, Serpent Mound in present-day Ohio was long mistaken for a natural hill or ridge, until careful surveys revealed it to be a massive, intentional earthwork shaped by human hands. When these examples are placed side by side, a striking pattern begins to emerge. Across the world, ancient builders seem to share a quiet understanding that certain knowledge, skills, and achievements were too important to be left exposed. They understood that societies rise and fall, that cultures can collapse, and that knowledge can be lost through war, disaster, or simple neglect. Instead of relying on written records which can be burned, censored, or forgotten, or on oral traditions which can fade over time, they chose a different path. They locked their achievements into stone, earth, and landscape itself. These monuments were designed to endure vast stretches of time while remaining hidden from those who might misuse, misunderstand, or destroy what they represented. This raises an important question. Why hide such incredible works instead of displaying them proudly? Modern civilizations build monuments to show power, celebrate success, and make sure they are remembered. But the thinking behind the concealment seen at Gunung Padang suggests a very different mindset. Its builders did not seem focused on dominance or fame. Instead, they appear to have viewed their creations as containers of knowledge, something fragile and dangerous if handled at the wrong time, yet invaluable if preserved for the future. To them, knowledge was not something to boast about, but something to protect. The natural world in which these early builders lived helps explain this choice. The earliest construction phases at Gunung Padang took place during the last glacial maximum, a time when the climate was wildly unstable. Massive environmental changes were not rare events, but recurring threats. Entire landscapes could transform within a few generations. Sea levels rose rapidly, volcanic super-eruptions darkened skies and cooled the planet, and climate shifts could wipe out whole cultures with terrifying speed. These people either witnessed such disasters firsthand, or inherited vivid memories of them through stories passed down over countless generations. In a world like that, survival depended not on showing off achievements, but on protecting what truly mattered. Concealment was not fear, it was strategy. What makes this even more remarkable is the timing of these concealment events. The major phases of burial at Gunung Padang seem to line up with periods of global environmental stress, including sudden climate reversals, massive volcanic eruptions, and rapid sea level rises. It is almost as if the builders understood that catastrophe followed patterns, that chaos returned in cycles, and that their monuments needed to be shielded during these dangerous windows of time. This suggests a deep awareness of long-term natural rhythms and social instability, far beyond what we usually credit to ancient societies. Such a strategy could not have been carried out by scattered individuals acting alone. Deliberately hiding monumental architecture requires extraordinary cooperation and long-term planning. Entire communities had to agree that preserving knowledge for distant futures was more important than immediate recognition. They had to maintain traditions, stories, and responsibilities across many generations, ensuring that the location and purpose of these hidden sites were not forgotten entirely. Even the act of concealment itself became a cultural institution, a shared duty passed from parents to children. In this light, the builders of Gunung Padang appear not as rulers seeking glory, but as temporary guardians of something far greater than themselves. They understood that their own civilization might one day vanish, yet they believed humanity would continue. Their monuments were not trophies, but time capsules. They were built to survive floods, fires, ice, and social collapse, waiting patiently for a future moment when people would be ready to rediscover them and understand their meaning responsibly. By choosing concealment over display, they showed a level of wisdom that few civilizations in recorded history have matched. They seemed to grasp that true greatness lies not in impressing those around you, but in protecting knowledge for people you will never meet. This idea becomes even more powerful when we consider that Gunung Padang may not stand alone. What if it is not the achievement of a single forgotten culture, but a central piece of a vast network spread across Indonesia's 17,000 islands? Seen this way, it becomes like a bright anchor point in a constellation of stone wisdom scattered across the world's largest archipelago. When researchers look beyond the terraced slopes of the Mountain of Light, a much larger picture begins to form. What once seemed like an isolated mystery starts to look like evidence of an entire civilization whose presence is etched into the Indonesian landscape itself. From the western shores of Sumatra to the highlands of Papua in the east, Indonesia holds an astonishing number of megalithic sites. Many were recorded during the Dutch colonial era, carefully documented and then quietly forgotten in academic archives. These structures are not crude piles of rock or simple burial markers. They are carefully engineered monuments that share common design principles, alignments with the sky, and construction methods that demand advanced mathematical thinking and complex social coordination. Taken together, they suggest not scattered experiments, but a connected culture with shared knowledge and purpose. If this network is fully understood, it may force us to rethink not only Indonesian history, but the true depth, reach, and wisdom of ancient human civilization itself. On Sumatra's Pasma Plateau, enormous stone figures rise out of the thick tropical forest, as if they were solid dreams turned into rock. Hidden for ages beneath vines and trees, these gigantic boulders, each weighing many tons, have been carefully carved into detailed images of warriors, elephants, and twisting serpents. The skill behind these carvings is so refined that it easily stands beside the stone art of ancient Greece. Yet their true importance goes far beyond beauty alone. These monuments were not placed at random. Their positions follow the movements of the sky with astonishing accuracy, forming open-air observatories that mark the turning points of the year, the longest and shortest days, the balance of day and night, and the repeating rhythms of the moon. Achieving this level of precision would have required careful watching of the heavens over countless lifetimes, along with mathematical thinking passed down from generation to generation. This same deep understanding of the sky links the Pasma Plateau directly to Gunung Padang. At both places, the builders clearly understood how the sun, moon, and stars move, not only in obvious cycles but also in far slower patterns. They even appear to have known about the long, slow wobble of Earth's axis, a cycle that takes roughly 26,000 years to complete and causes the stars themselves to slowly shift position over time. Knowledge like this cannot come from short observation. It demands organised traditions, shared memory, and social systems capable of preserving extremely complex information across hundreds of generations. Off Sumatra's western coast in the Indian Ocean, Nias Island offers a living connection to this ancient stone-building world. Here, traditional communities still perform dramatic stone-leaping ceremonies, where young men sprint forward and leap cleanly over tall stone pillars standing about 6 feet high. While these events appear to be displays of strength and bravery, they are much more than athletic challenges. The stones themselves are carefully placed monuments, built using the same techniques and guided by the same astronomical awareness seen at Pasma and Gunung Padang. Through these rituals, cultural memory survives. Stories passed down by word of mouth speak of ancestors who could speak to stone, who understood how the placement of rock could mirror the movements of the sky. The skills needed for stone leaping, perfect timing, balance, focus, and total commitment reflect the same discipline and precision required to plan and build megalithic monuments in the first place. On the island of Java, the scale of this tradition becomes even clearer. Java contains one of the greatest concentrations of megalithic sites anywhere in the region. From huge stone calendars in the heart of the island to carefully engineered stone tables scattered across its mountains, these structures follow shared design principles. Massive stone caps rest delicately on supporting pillars. Hidden chambers align with specific stars. Deep foundations reveal a strong understanding of how to build safely in areas shaped by earthquakes and volcanic forces. High in Java's central mountains, the Dieng Plateau reveals complexes where natural volcanic features blend seamlessly with human-made stonework. Here, ancient builders positioned monuments so the rising sun appears through mountain gaps at certain times of year, turning the landscape itself into a calendar that unites sky, stone, and land into one system. Farther east, Indonesia's megalithic traditions continue, adapted to new environments. On Flora's Island, stone platforms were raised to protect structures from seasonal floods. Foundations were designed for coral limestone ground, and stone channels guided heavy monsoon rains away from important sites. On Sumba Island, enormous stone tombs dominate the landscape. Some of these tombs required hundreds of people to move and lift single capstones weighing more than 30 tons. Organising such efforts demanded advanced planning, strong leadership, and engineering knowledge that challenges what we usually imagine for ancient societies. Even today, moving and balancing stones of this size without modern machines is an extraordinary task. When all these sites are viewed together, a powerful pattern emerges. These monuments are not scattered randomly, nor are they isolated achievements. Instead, they reflect shared building methods, common astronomical knowledge, and consistent mathematical ideas spread across thousands of miles and preserved over immense stretches of time. The builders of Indonesia's megaliths were not simply skilled craftsmen. They belonged to a connected culture capable of passing complex knowledge across oceans and generations. The remarkable similarities between distant sites suggest more than chance or simple imitation. They point to a civilization that understood the Indonesian archipelago as one connected world, using advanced navigation and communication to maintain shared traditions across distances that would challenge even modern travel. Seen in this light, Gunung Padang is no longer a strange exception. It becomes a powerful example of a much larger and more sophisticated system, whose full achievements we're only beginning to recognise. If people nearly 28,000 years ago could create the advanced foundations found at the so-called Mountain of Light, then countless other discoveries may still lie hidden beneath Indonesia's forests, soil, and volcanic slopes, waiting for the right tools and open minds to reveal their meaning. Even more astonishing are the mathematical relationships connecting these sites. When measured carefully, the distances between major megalithic centres follow precise ratios. The spacing between Gunung Padang, the Pasma Plateau monuments, and the stone structures of central Java forms patterns based on the golden ratio, a number that appears again and again in nature, from spiral galaxies to seashells to the proportions of the human body. These relationships are not rough guesses. Their accuracy suggests advanced surveying methods and systems of measurement, usually linked to far later civilizations. The mystery deepens when Indonesia's monuments are compared to ancient sites across the world. The distance from Gunung Padang to Easter Island forms mathematical relationships with the distance from Easter Island to Nan Madol in Micronesia, echoing the same proportional rules used in Greek temples and Gothic cathedrals. Such consistency across vast oceans is difficult to dismiss as coincidence. It suggests careful planning by people who understood advanced mathematics and global geography on a scale that challenges everything we assume about the ancient past. The frequent connection between megalithic sites and volcanic regions reveals yet another layer of understanding. These builders appear to have chosen locations not only for spiritual or symbolic reasons, but also because they recognized the deep links between Earth's inner forces, the movements of the heavens, and the mathematical order underlying both. In stone after stone, across island after island, Indonesia's ancient builders left behind a message written in rock, sky, and number, a message that humanity is only just beginning to read. Indonesia sits along the Pacific Ring of Fire, a vast belt of volcanoes that has shaped the land for countless ages. This position gave ancient builders access to powerful natural materials that were perfect for advanced construction. Sharp volcanic glass known as obsidian could be shaped into extremely precise cutting tools. Light volcanic stone such as pumice made it easier to move and stack large structures. Dense volcanic rock provided strong, long-lasting foundation stones. But this same volcanic setting also brought danger. Earthquakes, eruptions, and rivers of ash and mud were constant threats. Surviving in such a place required more than courage. It required deep knowledge and careful planning. The megalithic builders of Indonesia did not simply try to avoid volcanoes. Instead, they studied them and learned how to live with them. They understood how volcanic landscapes behaved over long periods of time and how those forces connected to wider natural cycles. Major stone sites were placed close enough to volcanoes to benefit from their rich materials, but far enough away to reduce the risk of destruction. This careful balance created a pattern across the islands where construction advantages were maximized, while long-term dangers from eruptions, earthquakes, and flowing debris were minimized. It shows a level of geological wisdom that goes far beyond simple trial and error. This understanding extended across entire landscapes. Natural features and human construction were blended into single, unified systems. On the Dieng Plateau, for example, stone monuments were carefully placed among volcanic craters, crater lakes, hot springs, and naturally shaped rock formations. These places became observatories, gathering grounds, and ceremonial spaces where human design worked hand in hand with the forces of the earth. The buildings do not look like they were forced onto the land. Instead, they appear to rise naturally from it, as if the landscape itself guided their creation. This suggests a philosophy where human achievement was seen as an extension of nature, not an attempt to overpower it. The same depth of understanding appears in the way these monuments were aligned with the sky. The astronomical positioning of Indonesian megaliths reveals precise mathematical relationships between the earth and the heavens. Achieving this kind of accuracy required more than simply watching the sun rise or the moon set. It demanded careful observation over many generations and complex mathematical thinking. The builders understood not only daily and yearly cycles, but also extremely long and subtle patterns. They accounted for the slow 26,000-year cycle, in which the stars gradually shift position in the sky. They understood the 41,000-year rhythm of changes in the tilt of the Earth's axis. They even tracked the roughly 100,000-year cycle of changes in the shape of the Earth's orbit, which influences the coming and going of ice ages. This level of knowledge suggests advanced modelling of the cosmos, not simple guesswork. Water was treated with the same respect and precision. The design of many megalithic sites shows a strong grasp of how water moves through the land. Ancient architects carefully studied seasonal rains, mountain springs, and river systems. They then built stone channels and pathways that guided water gently through their monuments. These systems prevented erosion, protected foundations, and created controlled pools and flows used for daily life and sacred rituals. The calculations behind these designs reveal a strong understanding of how rainfall, terrain, and human needs interact. Because of this, many sites remained usable for thousands of years, even as climates shifted and environments changed. This careful handling of water also carried deeper meaning. It shows that these societies did not see water only as a resource to be controlled, but as a living cycle to be honoured. Their engineering supported practical survival while also reinforcing spiritual beliefs. Human life, stone monuments, and flowing water were all part of one balanced system. Across Indonesia's vast chain of islands, stone circles served more than one purpose at the same time. Each one was a sacred place for local communities, but it was also a marker for travellers moving across land and sea. These monuments acted like beacons, helping long-distance voyagers understand where they were and where they were going. To do this, builders had to design structures that met local spiritual needs, while also fitting into a much larger navigation network. In this way, the monuments linked villages, islands, and cultures across both the Pacific and Indian Oceans. When viewed together, these sites reveal an extraordinary level of mathematical and scientific understanding. The builders did not see each monument as an isolated achievement. They understood them as parts of enormous systems that stretched across space and time. Their work connected geological forces, star movements, water cycles, and human culture into a single, enduring network. These stone structures became libraries of knowledge, designed to survive disasters and preserve wisdom long after softer materials and spoken traditions might be lost. This raises a powerful question. How did ancient builders move massive stones across hundreds of miles of open ocean, coordinate construction across thousands of islands, and maintain shared traditions across an archipelago that still challenges modern transportation? The scattered megaliths across Indonesia's more than 17,000 islands suggest maritime skills far older than conventional history allows. They point to navigation technologies and ocean knowledge that we're only beginning to appreciate. The practical challenges alone are staggering. Stones used at Gunung Padang were taken from quarries many dozens of miles away, requiring transport across rivers, valleys, and possibly sea channels. On the island of Sumba, the massive capstones placed atop megalithic tombs weigh more than 30 tons each. Moving stones of this size over water demands strong ships, an understanding of buoyancy and balance, and the skill to guide heavy cargo safely through unpredictable seas. Yet the evidence suggests abilities that go far beyond simple transport. The precise mathematical links between distant sites imply navigation methods capable of pinpointing locations across thousands of miles of open ocean. This level of accuracy requires advanced celestial navigation. Builders had to understand the movements of stars, the behavior of ocean currents, the timing of seasonal winds, and subtle signs in the natural world that signal direction and distance. Together, these skills reveal ancient mariners who crossed vast waters with confidence, guided by mathematics, astronomy, and deep environmental knowledge that rivals the most respected seafaring traditions in human history. Across the vast Pacific Ocean, living indigenous navigation traditions still preserve echoes of an ancient and remarkably advanced seafaring knowledge. These traditions offer us rare windows into how early ocean travellers crossed enormous distances long before compasses, maps, or modern instruments ever existed. In the Marshall Islands, for example, navigators continue to use stick charts, made from thin wooden rods and shells. At first glance, these charts look simple, but they are anything but. They represent ocean swell patterns with incredible accuracy, showing how waves bend, collide, and reflect around islands. These charts form three-dimensional models of moving water, allowing skilled sailors to sense their position at sea and travel across thousands of miles, guided only by the rhythm of the ocean itself. In Micronesia, navigators carry entire maps in their minds. They memorize star compass systems that divide the horizon into 32 precise directions. Each direction is linked to rising and setting stars, seasonal winds, and the flow of ocean currents. This knowledge creates a mental landscape of extraordinary depth, where the sky, sea, and weather are all woven together into a single navigational system. A sailor does not simply follow a star, but understands how that star relates to changing winds, shifting currents, and the time of year. Yet when we look at the vast network of Indonesian megalithic sites, it becomes clear that ancient navigation abilities may have gone even further. Building massive stone monuments across many islands would have required careful coordination, long-distance planning, and reliable communication. Stone, tools, food, and skilled labour had to move across open seas in a synchronized way. This level of organisation suggests either regular travel routes linking distant island communities, or perhaps even communication methods that have not yet been recognised by archaeology. What is often called the Austronesian expansion, which conventional archaeology places at around 3,000 years ago, may only represent the latest chapter of a much older maritime story. Genetic research reveals that people were moving across the Pacific far earlier than once believed. DNA evidence points to contact between Indonesian populations and distant Pacific communities during periods when such voyages were once thought impossible. These findings quietly rewrite the history of ocean travel. Successful navigation through Indonesian waters also demands deep understanding of monsoon cycles. Sailors had to know when winds would shift, when currents would strengthen, and when seas would calm. This knowledge goes beyond simple sailing skills. It reflects an understanding of large-scale weather systems and how they connect to farming seasons, astronomical events, and long-term climate patterns. Many Indonesian megalithic sites are placed where seasonal winds naturally support travel between islands at certain times of year. These monuments were not randomly located. They were part of transportation networks shaped by the wind itself, blending stone construction with the natural rhythm of the sailing seasons. With advanced seafaring skills, megalithic building techniques could spread across the Pacific. This helps explain the striking similarities between stone monuments separated by enormous distances. The precisely cut stones of Easter Island, the artificial islands of Nan Madol, and the raised stone platforms of Polynesia all display shared construction methods and deep astronomical knowledge. These similarities strongly suggest a shared cultural tradition carried across the ocean by skilled maritime peoples. Navigation and astronomy were not separate sciences. They reinforced each other. Megalithic monuments often served multiple purposes at once. They were ceremonial centres, agricultural calendars marking planting and harvest times, and visual markers that could guide sailors approaching land from far away. This multifunctional design allowed monument networks to survive across vast distances and long periods of time, supporting both local communities and the wider oceanic world that connected them. Traditional Indonesian navigation knowledge also preserves an understanding of ocean currents that hints at awareness of global circulation patterns. Such knowledge would have made transoceanic travel possible during earlier eras when sea levels, wind systems, and current flows were very different from those we know today. During the last ice age, when major construction occurred at Gunung Padang, ocean conditions may have opened sailing routes that later vanished as rising seas and shifting climates reshaped the world. Taken together, the megalithic builders of Indonesia emerged not just as skilled stoneworkers, but as true masters of the sea. Their knowledge reached far beyond monument building, encompassing astronomy, climate science, ocean dynamics, and the deep relationship between nature and human culture. Their civilizations blended practical navigation with spiritual meaning, environmental wisdom with technical innovation, creating traditions strong enough to preserve essential knowledge across immense stretches of time and space. Long-distance monument building required more than individual talent. It demanded social systems capable of teaching complex skills across generations, maintaining supply networks over thousands of miles, and coordinating projects that lasted centuries or even millennia. This level of organization challenges modern assumptions about prehistoric societies and their ability to plan on a grand scale. And it raises a profound question. What happens when 28,000 years of architectural and navigational wisdom survive not in books or ruins, but in living traditions passed down through communities who still build, sail, and navigate using knowledge shaped long before the pyramids, before Stonehenge, before any monument recorded in written history? Across the wide chain of islands that make up Indonesia, many traditional communities still hold on to ancient building knowledge that offers a rare and powerful glimpse into how people may have built, believed, and lived thousands upon thousands of years ago. These living traditions act like open windows into the past, revealing construction methods, spiritual ideas, and deep relationships with nature that may reach all the way back to the earliest builders of Gunung Padang. Among these communities, the Toraja people of South Sulawesi, whose architectural traditions show clear and striking links to Indonesia's ancient megalithic heritage. Their traditional houses, known as tongkonan, are far more than simple homes. Raised high above the ground, these structures are built using carefully calculated wooden joints that fit together so precisely they require no nails, screws, or metal of any kind. Every beam and post is shaped to lock into the next, forming a flexible yet incredibly strong framework. This design allows the buildings to bend and absorb movement during earthquakes, withstand powerful tropical storms, and endure decades of heat, rain, and humidity. The strength of the tongkonan does not come from brute force, but from carefully balanced proportions and mathematical relationships that spread weight evenly throughout the structure with remarkable engineering accuracy. Yet the tongkonan represents much more than technical skill. To the Toraya, a building is considered a living presence that must exist in harmony with its surroundings. Houses are carefully placed within the landscape, aligned with mountains, valleys, and rivers, and oriented according to the movement of the sun, moon, and stars. These alignments connect everyday human life to the rhythms of the sky, linking farming, ceremonies, and social activities to the wider universe. The proportions between different parts of the house follow traditional numerical patterns that create a sense of balance between human-made structures and the natural world. Building a tongkonan is never an individual task. It is a deeply communal event that brings together many layers of knowledge. Master carpenters apply inherited systems of measurement and proportion, passed down through generations. Spiritual leaders determine the correct timing and orientation based on celestial movements. Elders guide the process through oral histories that explain how humans should properly interact with nature and unseen forces. In this way, each house becomes a physical expression of shared memory, belief, and cooperation, preserving cultural knowledge that may stretch back to the megalithic age. Even more direct links to ancient stone-building traditions can be found among the Batak people of North Sumatra. Here, traditional stone chairs carved from single blocks of volcanic rock stand as powerful symbols of authority and ceremony. These chairs are not roughly shaped. They display smooth surfaces, precise angles, and carefully measured proportions that closely resemble the advanced stoneworking seen at ancient megalithic sites. The size and shape of each chair follow mathematical rules that appear nearly identical to those used in prehistoric stone monuments, suggesting that extremely old knowledge of geometry and proportion has survived within living culture. Batak traditions surrounding the creation of these stone chairs include ceremonies and stories that explain how stone should be chosen, shaped, and respected. Builders speak of stone as something alive, inhabited by spiritual forces that must be understood and honoured. These beliefs may preserve ancient knowledge about geological processes, how different types of stone behave, and which materials are best suited for carving and long-term stability. Technical skill and spiritual understanding are treated as inseparable, reflecting a worldview in which construction is both a practical and sacred act. The importance of these stone chairs extends far beyond a single village. Installing a new chair often requires the involvement of skilled individuals from multiple communities, creating networks of shared knowledge that stretch across large regions. Through these gatherings, techniques, measurements, and ceremonial practices are exchanged and reinforced. This system of cooperation may echo ancient cultural institutions that once allowed large-scale megalithic projects to be coordinated across Indonesia's enormous island network. Similar principles appear throughout the archipelago, from the elevated wooden houses of the Dayak people in Borneo to the stone platforms of traditional Javanese communities. Consistent patterns emerge. Buildings are designed using mathematical proportions, aligned with celestial events, and carefully integrated into their surrounding environment. Together, these living traditions offer practical clues to how Indonesia's earliest builders may have constructed their monumental sites. Much of this knowledge faced severe disruption during the colonial era. Dutch rule, followed by Japanese occupation and later modernization efforts, weakened traditional institutions that once protected and transmitted ancient wisdom. Skilled builders were often forced into wage labour, while younger generations were educated in modern systems that ignored or dismissed traditional knowledge. Entire chains of learning came close to being broken. Despite this, many communities recognized the immense value of what they held. Elders and cultural leaders made deliberate efforts to protect traditional construction methods, preserve ceremonies, and pass specialized knowledge to younger members. Because of these efforts, crucial elements of ancient building wisdom have survived into the present day. Today, collaborations between traditional knowledge holders and academic researchers are beginning to reveal just how advanced these systems truly are. Master builders possess hands-on understanding of materials, structural behaviour, and environmental interaction that no excavation alone could ever uncover. When combined with archaeological evidence, this living knowledge paints a picture of astonishing sophistication. These traditions show that Indonesia's ancient megalithic builders were not simply skilled technicians. They held a deep philosophical understanding of how humans, nature, and the cosmos are interconnected. Their knowledge systems were sustainable, capable of surviving across hundreds of generations without written records. Living traditions may offer the clearest and most direct link to the minds of Indonesia's ancient builders, keeping alive the same principles that once shaped monuments like Gunung Padang. They suggest that the wonders of megalithic architecture did not arise from lost or mysterious technologies, but from balanced systems that combined practical skill, environmental awareness, and spiritual insight. And perhaps the most remarkable possibility of all is this. What if the greatest archaeological discoveries are not buried beneath layers of soil, but carried within living memory? Oral traditions passed down for 28,000 years, with each generation adding its voice to an unbroken story that reaches back to the very first builders who raised stone monuments toward the sky. Across Indonesia's enormous chain of islands, many traditional communities have carefully passed down spoken histories that are far more detailed than simple myths or legends. These stories describe ancient builders with surprising clarity, explaining who they were, how they worked, what they believed, and how their world was forever changed by massive natural disasters that reshaped the land and scattered their descendants across far-flung islands. In Java, the traditions surrounding the Wali Pitu, the 7 sacred saints remembered for bringing Islam to the island, are layered with much older stories beneath the surface. Hidden within these accounts are descriptions of master builders whose skills went far beyond anything known from recorded history, preserved through shadow puppet performances in the wayang kulit tradition and written court chronicles of Javanese kingdoms. These tales speak of architects who could speak to stone, who understood how the careful placement of massive blocks could link monuments on Earth with the movements of the stars and planets above. They were said to possess construction knowledge so advanced that their structures were designed to survive floods, earthquakes, and dramatic environmental changes. These oral traditions never describe the ancient builders as crude or primitive people struggling with basic tools. Instead, they are remembered as highly refined masters of both practical engineering and spiritual knowledge. They understood mathematical ideas well enough to create precise astronomical alignments, developed methods for producing tools capable of shaping the hardest volcanic stone, and maintained organised cultural systems that allowed enormous building projects to be coordinated across great distances and long periods of time. Most fascinating of all, these stories often say that the builders did not see themselves as owners of this knowledge. They believed they were only temporary caretakers, preserving wisdom that belonged to all humanity and was meant to endure across vast stretches of time. Oral histories from deep within the forests of Borneo tell even more specific and striking stories. These traditions speak of sky people, who came down from the heavens to teach humans how to shape stone, observe the stars, and live in balance with the natural world. These accounts are not vague or symbolic. They include clear descriptions of how tools were made, how stones were measured and positioned, and how buildings were designed. Details that closely match the advanced engineering seen at sites such as Gunung Padang. The stories describe master builders who could calculate the exact placement of enormous stones, who understood how to create stable structures in regions prone to earthquakes, and who used sophisticated surveying methods to align monuments accurately across long distances. The traditions known as the DAK accounts preserve remarkable insight into how such massive construction efforts were organised. They describe coordinated groups of workers brought together from communities separated by hundreds of miles, temporary settlements built near construction sites to house workers during projects that lasted many years, and ceremonial practices that blended practical labour with spiritual rituals meant to protect and stabilise the finished monuments. Just as important, these oral histories explain how ancient builders deliberately hid their creations when conditions changed. As climates shifted and societies faced upheaval, the builders understood that certain sacred sites and forms of knowledge needed protection. they developed ways to disguise monuments as natural features of the landscape and created cultural roles responsible for secretly maintaining these hidden places across generations, especially during times when such knowledge might be misunderstood or misused. Palm leaf manuscripts known as the Balanlar texts offer written versions of these ancient oral traditions. They describe civilizations that existed before great floods, societies whose technological and spiritual abilities were said to surpass those of later historical periods. Written in ancient scripts that require special training to read, these texts speak of kingdoms that thrived when Java, Sumatra and Borneo were still connected by land bridges. What is most striking is the consistency of these stories across Indonesia's many languages and cultures. Javanese, Dak and Balinese communities developed separately for thousands of years, yet their traditions describe nearly identical building techniques, social systems and spiritual practices related to megalithic construction. Such agreement across cultures that rarely interacted strongly suggests these stories preserve genuine memories of a shared past, from a time when Indonesia's geography allowed much closer cultural unity. When researchers compare these oral traditions with archaeological discoveries from around the world, the similarities become even more remarkable. Descriptions of precise stone cutting, careful control of sound and acoustics, alignment with celestial bodies, and foundation designs built to withstand earthquakes closely match what is found at megalithic sites from Easter Island to Stonehenge. This suggests that Indonesia's oral histories may preserve real memories of advanced technological achievements belonging to a globally connected civilization of extraordinary sophistication. Again and again, these stories describe the ancient builders as wise individuals who combined technical skill with deep understanding of nature, human behavior, and long-term environmental and cultural cycles. They were not merely engineers, but philosophers who saw their monuments as temporary vessels of knowledge, meant to survive disasters that might erase their own societies. Their goal was not dominance or power, but preservation, ensuring that essential wisdom could be rediscovered when future generations were ready to understand and use it responsibly. In this way, the traditions do more than recount ancient achievements. They pass on lessons about sustainable living and respectful relationships between humans and the natural world. The builders understood their monuments as quiet guardians of knowledge, designed to endure whatever catastrophes might come, safeguarding humanity's shared wisdom across geological ages, astronomical cycles, and the unpredictable resets of human civilization. What level of geographic accuracy would be required for spoken traditions to preserve clear descriptions of landscapes now buried beneath 400 feet of ocean water for 15,000 years? Indonesian flood stories are filled with geographical details that are so clear, so consistent across many different communities, and so closely aligned with modern scientific knowledge about rising sea levels after the last ice age, that they may represent one of the greatest examples of long-term human environmental memory ever preserved. These stories do not read like vague legends or symbolic tales meant only to teach moral lessons. Instead, they describe real places, real landscapes, and real changes to the land in ways that modern geology now confirms with striking accuracy. The Javanese Babad Tanah Jawi chronicles speak of a great flooding that completely reshaped the land. They describe a time when wide plains stretched continuously from Java to Sumatra, when travellers could walk for days through endless coconut groves, and when vast river systems flowed across lands that today lie hidden beneath the sea. These rivers are said to have carried water across enormous distances, carving paths through territories that are now submerged. The chronicles also describe mountain peaks rising above the waters like islands of safety, places where people fled when the sea returned to reclaim the land that melting ice had once revealed. What makes these descriptions remarkable is how closely they match modern reconstructions of sea level rise after the Ice Age. These accounts are not poetic exaggerations or symbolic flood imagery found in many cultures around the world. They contain precise navigational and geographical details that allow modern researchers to identify drowned river valleys, ancient shorelines, and elevated regions that would have remained above water during periods of rapid flooding. The accuracy of these details suggests that real environmental knowledge was carefully preserved and passed down through oral storytelling over hundreds of generations, long before writing existed. Flood traditions from Sumatra describe the sinking of Sunderland with an almost scientific clarity. They explain how rising seas slowly broke apart lands that were once connected, turning continuous territory into scattered islands. The stories tell of entire populations being forced to move toward higher ground, as water-filled river valleys, separated mountain ranges, and transformed familiar hunting grounds and settlements into open sea. These migrations are described as happening gradually, season after season, year after year, across spans of time long enough to encompass multiple human generations. Among the most detailed of all are the Bahak traditions of northern Sumatra. Their oral histories describe ancient river systems, mountain passes, and territorial boundaries that align closely with the shape of the Sunda Shelf as revealed by modern underwater mapping. The stories speak of hunting lands, trade routes, and sacred places that correspond to submerged features, identified by geological surveys. This suggests that these traditions preserve genuine memories of landscapes that vanished beneath the ocean roughly 15,000 years ago, carried forward entirely through spoken word. Flood stories from the Dayak peoples of Borneo describe a great dispersal, when rising waters forced communities apart that had once lived in regular contact across now submerged lands. These traditions tell of people retreating into the highlands, learning new ways to travel across water, and adapting their cultures to survive in an emerging island world. They speak of the loss of large continental territories and the painful adjustment to life scattered across seas, a transformation that replaced the stable lands where their ancestors had developed advanced stone-building traditions. One theme appears again and again across Indonesian flood stories: mountains as places of refuge. These are not symbolic or spiritual metaphors. The stories specify which elevations provided safety, which slopes were suitable for emergency settlements, and which geographical features allowed communities to stay connected even as their world collapsed around them. Modern geological studies confirm that the elevations described in these myths match areas that would have remained above water during the fastest and most dangerous phases of sea level rise. On the island of Flores, flood traditions describe the drowning of large land areas with such detail that researchers can reconstruct ancient connections between islands now separated by deep ocean channels. The stories describe walking routes that once linked different regions, routes that required careful timing around tides as waters rose. They speak of river crossings that slowly became impossible, and of familiar landscapes transforming into strange and dangerous seascapes that challenged navigation, travel, and cultural survival. The Maluku, or Spice Islands, preserve flood traditions describing how their region changed from broad lowlands into the scattered island chains later encountered by European explorers. These stories recount the loss of fertile spice-growing lands, the movement of agriculture to higher ground, and the development of new farming techniques suited to changing soils, drainage patterns, and seasonal weather. They show an understanding of environmental change that goes far beyond simple myth, revealing careful observation and adaptation. Perhaps most striking of all, Indonesian flood stories consistently describe deliberate efforts to preserve knowledge in the face of inevitable disaster. They tell of master builders who prepared hidden refugees, who developed methods to protect important knowledge during times of chaos, and who created cultural systems designed to survive when normal teaching and social structures broke down. These descriptions closely match archaeological evidence of intentional concealment at sites such as Gunung Padang, suggesting that these stories are rooted in real historical strategies for survival. Indonesian communities created powerful oral tradition systems with a clear purpose: to protect vital knowledge about the land, the environment, and cultural wisdom during times when disasters repeatedly wiped the slate clean for human societies. These traditions were not casual stories told for entertainment. They were carefully designed memory systems meant to survive earthquakes, volcanic eruptions, rising seas, social collapse, and mass migration. Through them, ancient people passed down the practical skills and deep, philosophical understanding needed to prepare for catastrophe, endure it, and rebuild afterward. They show that our ancestors understood that survival depended not only on tools and structures, but on preserving knowledge itself. This raises an extraordinary question. What kind of cultural systems would be necessary to protect advanced architectural knowledge across roughly 28,000 years of environmental chaos, social upheaval, and cultural change spread across thousands of islands? Across Indonesia, The answer still exists in living traditions. Many traditional communities preserve specialized roles for master builders, guardians of knowledge, and cultural protectors. These individuals are not simply construction workers. Their responsibility goes far beyond building houses or temples. They serve as living libraries, carrying ancient wisdom that links present-day communities directly to the achievements of their earliest ancestors. Among the most remarkable examples are the Andi of Bali, who may represent the most advanced surviving system for preserving ancient architectural knowledge anywhere in the modern world. These traditional master architects maintain a deeply integrated knowledge system that blends mathematics, astronomy, and spiritual practice into a single living tradition. The way they think, measure, and design mirrors the abilities seen at Indonesia's ancient megalithic sites. Training to become an Andi is not quick or simple. It takes decades of disciplined learning. Apprentices study not only how to build, but how proportions must relate to one another, how ceremonies guide construction, and how buildings must fit naturally into the surrounding landscape rather than dominate it. Within Andi training, ancient measurement systems are preserved that clearly connect back to Indonesia's megalithic past. One example is a unit of measurement based on the length of the human forearm, a system that appears again and again in traditional Indonesian architecture. This measurement is not used in isolation. It forms part of complex proportional relationships that create the sense of balance and harmony also visible in massive ancient stone monuments. These are not simple straight-line measurements. Andi traditions preserve layered mathematical systems that combine multiple units and ratios. These systems take into account the movement of the stars, the changing seasons, and the unique geographical features of each building site. Sacred measurement traditions, preserved in unagi practices, extend beyond individual structures. They map relationships across entire landscapes. Temples, mountains, rivers, and coastlines are positioned in meaningful mathematical and spiritual patterns, suggesting that this knowledge once supported vast networks of megalithic sites stretching across enormous distances. Traditional Balinese temple complexes demonstrate this clearly. Their locations are not random. They form precise relationships with distant temples, mountain peaks, and water sources in ways that closely resemble the large-scale planning seen at ancient stone sites throughout the Indonesian archipelago. Architectural knowledge is also preserved in unexpected ways. Javanese court chronicles protect deep architectural memory through the work of master puppeteers. In shadow puppet performances, cultural memory is carried forward through story, rhythm, and symbol. These performances preserve knowledge of building techniques, spiritual customs, and historical events that reach far beyond the Islamic period and deep into prehistoric time. The great epics, including the Mahabharata and the Ramayana, as performed in traditional wayang kulit, describe architectural feats that match the abilities seen at megalithic sites, and often surpass anything recorded in later historical periods. The training of a traditional dalang, or master puppeteer, is astonishing in itself. It requires memorizing thousands of characters, voices, story variations, and cultural details. This functions as a sophisticated mental archive. Within these performances, architectural knowledge is not presented as dry instruction. Instead, it is woven into stories, symbols, and rituals that make it unforgettable, even during times of war, conquest, or cultural collapse. Proportions, construction sequences, and ceremonial practices are preserved as living narratives that survive when written records fail. Written court chronicles further extend this deep historical memory. From the Babad chronicles of Javanese kingdoms, to the Paraton texts of East Java, to the Hikayat traditions of Malay courts, these records describe architectural achievements, technologies, and cultural practices with striking consistency. Modern historians often dismiss them as myths, yet their descriptions repeatedly align with physical evidence found at Indonesia's ancient stone sites. Together, they reveal a sophisticated understanding of how to preserve complex information across extremely long periods of time and unpredictable social conditions. Indonesian societies did not rely on a single method to safeguard knowledge. They built overlapping systems, specialized education trained master builders, ceremonies embedded technical understanding into spiritual life, written records documented cultural achievements, performance traditions transformed complex information into memorable stories. Modern efforts to document these fading systems have revealed just how advanced they truly are and how directly they connect to Indonesia's most ancient cultural accomplishments. Collaborations between scholars and traditional knowledge holders show that Andi architectural principles, Wayang performance traditions, and court chronicles all preserve practical understanding of construction, astronomy, and environmental integration. These systems provide rare insight into the capabilities of Indonesia's earliest builders. At the same time, documentation efforts reveal how close this knowledge came to total extinction. During the colonial period, Dutch policies systematically weakened traditional education. Later, Japanese occupation and modernization pressures forced many knowledge holders to abandon their roles in order to survive through wage labor. Within a single generation, wisdom representing roughly 28,000 years of cultural achievement nearly vanished. Yet survival prevailed. Through determined efforts by traditional communities, supported by growing recognition that this knowledge represents an irreplaceable cultural treasure, essential elements were preserved. Master builders continue to train apprentices. Ceremonial leaders protect rituals that encode architectural knowledge within spiritual practice. Elders maintain oral traditions that tie present-day life to its deepest ancestral roots. When traditional knowledge is combined with modern archaeological research, a powerful picture emerges. Indonesia's ancient builders possessed not only advanced technical skills, but also highly refined cultural systems for preserving and passing on complex knowledge across immense spans of time. The same societies that created monuments like Gunung Padang also created institutions capable of carrying wisdom through roughly 28,000 years of environmental and social transformation. These systems show that the impressive abilities seen in Indonesia's megalithic sites were not the result of mysterious lost technologies. They were the outcome of sustainable knowledge traditions that viewed individual civilizations as temporary, but wisdom itself as enduring. The builders did not only raise monuments, they designed cultural systems meant to survive catastrophe, ensuring that future generations could rediscover and responsibly apply ancient understanding when the time was right. Traditional knowledge keepers continue to preserve the insight that the greatest achievement of these ancient societies was not stone, scale, or strength, but wisdom about balance between human communities, the natural world, and the long cycles that shape both culture and environment. This wisdom, still alive in Indonesian traditions today, may be the most valuable inheritance left by one of humanity's earliest and most sophisticated civilizations. What if the great mythological stories passed down across Indonesian culture are not fantasy at all, but carefully designed systems for encoding geographical knowledge? What if they preserve exact information about ancient landscapes, cultural boundaries, and the locations of important sites now hidden beneath jungles or lost beneath the sea? When mythological study is combined with modern archaeology, the results are striking. Traditional Indonesian narratives contain geographical details so precise, so consistent, and so closely matched to physical evidence that they may represent one of the most advanced mapping systems ever created by human culture. The Indonesian sections of the Ramayana are far more than legendary stories. They are astonishingly precise records of geography, culture, and architecture. They describe the relationships between lands, the territories of ancient peoples, and their remarkable construction achievements with such accuracy that modern researchers can match them to real locations, archaeological sites, and cultural features in Indonesia. These narratives of kingdoms, palaces, and sacred places are not mere myth. They function as detailed cultural maps, preserving knowledge of Indonesia's ancient world for generations. Traditional Javanese interpretations of the Ramayana allow scholars to pinpoint where major events took place. For example, Langkah-Langkah aligns with regions of East Java, where sophisticated archaeological sites reveal evidence of advanced architecture and technology, just as the epic describes. Rama's bridge, which links distant lands in the story, corresponds with land bridges that existed during periods of lower sea levels, hinting that the epic may retain memory of Indonesia's landscape from times when islands were connected by exposed continental shelves. The potential for archaeology across these Ramayana locations is extraordinary. From Sumatra, which corresponds to several kingdoms mentioned in the epic, to Bali, where temple complexes claim direct links to sites in traditional narratives, investigations consistently uncover highly developed cultural remains. These discoveries match the epic's descriptions, suggesting that these mythological accounts preserve real historical and geographical knowledge rather than pure fantasy. Even Buddhist Jataka tales referencing Indonesian kingdoms contain precise geographical information, allowing scholars to locate lost cultural sites and understand ancient territorial relationships. These stories recount trade networks, cultural exchanges, and architectural achievements that match archaeological evidence for sophisticated Indonesian civilizations. These societies were deeply connected to wider Asian networks, even during periods considered prehistoric. Jataka references to the spice trade, complex harbour systems, and cultural accomplishments demonstrate that these tales preserve authentic memories of Indonesian civilizations that reached extraordinary levels of sophistication long before conventional archaeology would have expected. These narratives also include practical information, navigation routes, seasonal cycles, and cultural practices that guide modern archaeological work. In Borneo's interior, oral traditions serve as detailed topographical maps of areas now submerged or dramatically altered by environmental change. The stories of rivers, mountains, and territorial boundaries align precisely with the geography of the exposed Sunda Shelf, preserving knowledge passed down for 15,000 years through environmental transformations. The Dak traditions, in particular, map ancient cultural sites, inter-community territories, and environmental features that supported complex societies when Borneo was connected to mainland Southeast Asia. Balanlar texts add another layer of sophistication, encoding astronomical knowledge, geographical details, and cultural achievements in memorable story forms. These narratives describe kingdoms, monumental architecture, and cultural practices that match archaeological evidence, while embedding information in ways designed to survive social disruption. By combining astronomical and geographical knowledge, these myths created mapping systems that connected earthly locations with celestial patterns, offering practical navigation guidance and philosophical understanding of the relationship between human societies and the cosmos. Across Indonesian mythologies, it becomes clear that narratives were not just entertainment, they were resilient systems of knowledge. Stories preserved practical geographical data, technical astronomical insight, and wisdom about sustainable cultural development. They were designed to survive catastrophes that destroyed written records, monuments, and even dispersed communities across vast distances. These myths endured because they were valuable, repeatable, and meaningful across generations. Modern archaeology consistently confirms these insights. Sites identified through mythological geography reveal sophisticated cultural remains, proving that Indonesian civilizations developed highly effective systems for preserving knowledge over thousands of years. The lessons are profound. Ancient Indonesians possessed both the practical understanding and cultural wisdom needed to safeguard crucial information across environmental and social upheavals. These traditional narratives preserved not only the memory of past achievements, but also ongoing guidance about landscapes, natural patterns, and cultural possibilities, knowledge still relevant today for communities seeking sustainable ways to inhabit and develop their lands. The builders of Indonesia's megalithic monuments did not simply possess advanced technical skills, they created cultural technologies that safeguarded knowledge across tens of thousands of years. Just as monuments were designed to survive 28,000 years, the narrative traditions were crafted to preserve essential information across equally vast spans of cultural and environmental change. What happens when the tools of the 21st century meet mysteries that are 28,000 years old? When instruments capable of peering through solid rock encounter monuments, crafted by architects whose skills seem far beyond what we imagine early humans could achieve, the study of Gunung Padang becomes nothing short of extraordinary. It stands as perhaps the most advanced archaeological investigation ever undertaken at a single site. Yet each new discovery raises even deeper questions. Who were these builders? How did they achieve such engineering marvels? And why did they hide their incredible constructions beneath layers of earth and later structures? Ground-penetrating radar surveys of Gunung Padang reveal hidden structures beneath the surface that are astonishingly precise, mathematically sophisticated, and vast in their underground complexity. The electromagnetic signals penetrate deep into the hill, detecting massive, carefully shaped stone columns arranged in exact geometric patterns. Artificial chambers connect through deliberate passageways, and foundation systems stretch far beyond the visible surface, plunging into the hill's bedrock core. These are not crude stone piles or random caves. The radar shows architectural planning demonstrating advanced knowledge of structural engineering, geometry, and long-term stability. Some chambers align perfectly with astronomical phenomena, while the connecting passageways follow mathematical principles, suggesting highly advanced surveying techniques and architectural systems. The scale of these hidden constructions dwarfs the visible surface megaliths, revealing that what tourists see today is only the tip of a monumental complex, much of which remains buried and unexplored. Electrical resistivity tomography offers even more detailed insight. By measuring variations in electrical conductivity, scientists can distinguish solid rock from hollow spaces and even detect differences in material composition. This method not only confirms the existence of artificial cavities, but also provides precise information about their size, internal structures, and the materials used. Some chambers rival the great halls of medieval cathedrals in scale, maintaining structural integrity despite being buried under immense weight. The precision of construction implies engineering skills usually associated with advanced civilizations capable of complex mathematics, project planning, and construction technology. These spaces were not random caves, but carefully designed chambers with calculated dimensions, positioned openings, and architectural layouts that suggest specific purposes: ceremonial, practical, or both. Seismic surveys add another dimension by mapping the hill's interior in 3 dimensions using sound waves. These investigations reveal the most shocking discoveries. The artificial structures reach astonishing depths, carved into solid bedrock using techniques that challenge our understanding of prehistoric tools. The data shows multiple construction phases, descending through layers of geological deposits that formed over thousands of years, yet maintaining deliberate architectural connections with surface features. This implies long-term coordinated planning that spanned vast environmental and cultural shifts. Even more remarkable, acoustic surveys detect signs of intentional sound engineering within the hidden chambers. Certain structures appear designed to manipulate sound, producing specific auditory effects. This mirrors sophisticated sound design seen at other megalithic sites worldwide, from the resonance chambers of Stonehenge to the acoustics of Malta's Hypogeia, suggesting that the builders of Gunung Padang understood principles of sound physics and its potential effects on human consciousness and ceremonial practice. Conducting archaeology here is especially complex because Gunung Padang is not just an ancient site, it is a living landscape. Contemporary Indonesian communities consider the hill sacred. Their spiritual rituals, farming, and daily lives are deeply intertwined with the physical and cultural terrain. Researchers must navigate these living traditions with care, ensuring that scientific study does not harm the ancient structures or disrupt local practices. Yet this coexistence provides extraordinary opportunities. Generations of local knowledge offer insights into the site's properties, seasonal patterns, and subtle environmental cues, clues that modern technology alone might never reveal. Integrating traditional knowledge with scientific methods has uncovered correlations between oral histories and empirical data that neither could achieve on its own. Modern scientific investigation ultimately confirms what Indonesian oral traditions have long preserved. Gunung Padang hides architectural accomplishments that rank among humanity's most sophisticated prehistoric constructions. Yet each technological breakthrough seems to pose more questions than answers, transforming the site from a remarkable archaeological find into a profound challenge to our understanding of human cultural development, technical skill, and the intricate relationship between human achievement and environmental change. Radiocarbon dating adds yet another layer of mystery. These monumental constructions appear to have been built at times when conventional archaeology believes humans lived only in small, scattered, hunting and gathering groups barely surviving the harsh Ice Age conditions. The timeline itself becomes a puzzle, forcing us to reconsider the limits of prehistoric human capability. The dating of Gunung Padang presents one of the most perplexing and controversial mysteries in modern archaeology. Multiple independent scientific methods suggest timelines so ancient that, if confirmed, they could completely rewrite our understanding of human cultural history. Yet these same dates clash so sharply with conventional assumptions about what prehistoric humans could achieve that many in the scientific community find them almost impossible to accept. Carbon dating of organic materials trapped between different construction layers reveals astonishing results. Charcoal fragments, pieces of wood, and traces of organic soil extracted from drill cores in the deepest foundations of the site return radiocarbon dates ranging from 25,000 to 30,000 years, 28,000 years before the present. If these dates truly reflect the timing of construction, it would mean that sophisticated megalithic stone architecture existed in the midst of the last glacial maximum, a time when ice sheets blanketed much of the northern hemisphere and global conditions were thought to prevent large-scale social organization or advanced technological development. But interpreting these dates is not straightforward. Radiocarbon dating only tells us when the organic materials were deposited, not precisely when the stones were moved or monuments built. These samples could represent natural accumulation of plant debris, later disturbances of older layers, or contamination from younger material that seeped into older deposits. To distinguish between organic matter that genuinely reflects construction activities and material that might mislead, archaeologists must carefully analyze how each sample was deposited, its relationship to surrounding layers, and the complex geological processes that can mix materials from vastly different time periods. Adding weight to these startling dates, thermal luminescence dating of heated stones and ceramics provides independent confirmation. This technique measures radiation damage accumulated in crystalline materials that were heated to high temperatures during human activity, offering a direct way to date when stones were shaped using fire-based tools or when ceramics were fired. Analysis of stone samples from Gunung Padang's deepest construction layers shows dates that align closely with the radiocarbon results, suggesting that sophisticated stonework indeed occurred during the period from 25,000 to 28,000 years ago. The convergence of multiple dating techniques makes a compelling case for extremely ancient human construction, but it also raises profound questions about the society that could have produced such achievements. Thermal luminescence shows that these stones were deliberately worked at high temperatures using advanced techniques, while radiocarbon dating indicates these feats happened during a time when conventional archaeology would assume humans lived in far more primitive conditions. The site's stratigraphy adds further complexity. Gunung Padang exhibits at least 5 distinct construction phases, each separated by thousands of years, involving extensive excavation, movement of massive stones, and reshaping of the landscape. Later phases could have reused older stones, disturbed earlier organic deposits, or created mixed layers, making it difficult to link specific materials with specific construction activities. Advanced stratigraphic analysis attempts to identify primary deposition contexts where samples reliably correspond to the construction events, but this process requires careful interpretation and remains vulnerable to errors. The difficulties in dating Gunung Padang highlight the limitations of traditional archaeological methods. Most dating techniques were developed for sites with simpler histories and clearer connections between artifacts and human activity. In contrast, the multi-phase, deeply layered construction at Gunung Padang stretches these methods to their limits and challenges their reliability. Moreover, the implications of these ancient dates force archaeologists to rethink basic assumptions about cultural development, environmental adaptation, and technological innovation in prehistory. Independent verification through multiple dating techniques is essential to resolving these controversies. So far, every method applied, radiocarbon dating, thermal luminescence, optical stimulated luminescence of quartz grains, paleomagnetic analysis of stone orientations, and uranium series dating of mineral deposits, supports the possibility of construction during a window between 25,000 and 28,000 years ago. The agreement between these independent lines of evidence strengthens the argument for extremely ancient monumental architecture. Yet the broader implications continue to spark debate. If anatomically modern humans could organize large-scale, sophisticated construction projects nearly 28,000 years ago, it raises profound questions about what other capabilities our species might have developed over the 200,000 years of human evolution that preceded recorded history. The evidence from Gunung Padang invites us to reconsider the very nature of human achievement, pushing the limits of what we thought possible in prehistoric times. Microscopic analysis of the megalithic stones reveals astonishing precision. The surfaces display cutting marks, smooth finishes, and geometric modifications that suggest advanced tool use, techniques requiring skill and knowledge far beyond what we typically assume for societies of that era. These marks are preserved despite millennia of weathering, and careful study can distinguish deliberate human work from natural geological processes. Quarry analyses show that the builders sourced volcanic andesite stones from specific formations miles away, demonstrating sophisticated planning, knowledge of stone properties, and logistical skill in moving multi-ton blocks across challenging terrain. For countless generations, long before written history arrived in the Indonesian islands, the hill now known as Gunung Padang lay quietly beneath a thick cover of jungle. Vines wrapped themselves around stone. Trees pushed their roots deep into the earth and between cracks in ancient rock. Birds nested where humans once walked. Rain, mist, and sunlight slowly erased the sharp edges of whatever had been built there. To the outside world, it was just another forested hill rising gently from the land of West Java. But to the local people, it was never just a hill. It was a place of stories, warnings, respect, and memory. Elders spoke of it in low voices. Children were taught not to treat it casually. Myths wrapped the place in meaning, turning it into something both sacred and distant. In this way, the site slept, protected not by fences or guards, but by belief. For centuries, this quiet protection was enough. The jungle concealed the stones, and tradition concealed their significance. The local people believed the hill was connected to a legendary ruler, King Siliwangi, a powerful figure said to possess wisdom, strength, and supernatural abilities. According to the stories, the king had tried to build a palace in a single night. When the sun rose before the work was finished, he abandoned it, leaving behind a structure frozen in time. To modern ears, this sounds like myth, but myths often grow around real places, shaping memory when written records fade. In many ancient cultures, stories acted as libraries, carrying fragments of truth through metaphor and symbolism. Gunung Padang was one such place, where memory and stone became intertwined. The outside world did not remain ignorant forever. As European powers expanded across Asia, Africa, and the Americas, they began to catalogue everything they encountered. Mountains were measured, rivers were named, plants were classified, cultures were studied, often through a narrow and self-serving lens. The Indonesian archipelago, rich in resources and strategic importance, became a focal point of colonial ambition. Under Dutch rule, scholars and officials were sent to document the land and its people. This was not purely an act of curiosity. Knowledge meant control. To understand a place was to rule it more effectively. It was in this atmosphere that Gunung Padang first caught the attention of European scholars. In the year 1914, when the Dutch East Indies stood as a prized possession of the Netherlands colonial empire, a man named Nicholas Johannes Krom travelled into the interior of West Java. Krom was not an adventurer chasing treasure. He was a trained historian and archaeologist, known for his careful methods and attention to detail. Working with the Dutch Archaeological Service, his task was to investigate and record ancient sites, especially those that could shed light on the region's past. Krom did not set out specifically looking for Gunung Padang. Instead, he followed rumours. Plantation owners, local workers, and guides spoke of a strange hill where stones stood upright like soldiers. They described walls and steps hidden beneath the forest canopy. These stories intrigued Krom, not because he believed in myths, but because repeated accounts from different sources often pointed to something real. Guided by local knowledge, he made his way through difficult terrain. The jungle was thick and unforgiving. The air was heavy with moisture. Every step required effort. Insects buzzed constantly. The smell of wet earth, rotting leaves, and living plants filled the air. This was not an easy journey, and it was not one many Europeans would have chosen lightly. When Krom finally reached the hilltop, what he saw stopped him in his tracks. Rising from the vegetation were not scattered stones, but carefully arranged structures. There were terraces climbing the hill in steps, each one supported by walls made of tall volcanic basalt columns. These columns were not naturally lying where they were found. They had been placed, stacked, and aligned with purpose. Pathways ran between them. Enclosures suggested spaces meant for gathering or ritual. This was not the work of chance or erosion. It was architecture. Krom understood the importance of what he was seeing. In his official report, he described Gunung Padang as a significant megalithic complex, likely built in prehistoric times. He noted the local reverence for the site and its connection to the legends of King Siliwangi. He recognized that this place had meaning far beyond its physical form. Importantly, he urged that the site deserved further, more professional investigation. He believed that only a full archaeological expedition could reveal its true nature and age. And then, almost unbelievably, nothing happened. Crom's report was filed away in colonial archives. His call for deeper study was ignored. No major expedition followed. No detailed excavation was planned. The site slipped back into obscurity, not under jungle this time, but under bureaucracy and indifference. For more than 6 decades, Gunung Padang remained largely untouched by modern science. This long silence raises uncomfortable questions. On the surface, practical explanations are easy to find. Archaeological resources were limited. Scholars focused on more accessible and already famous sites like Borobudur and Prambanan, massive temple complexes that fit neatly into known historical timelines. These sites were easier to study, easier to promote, and easier to understand within existing frameworks of history. But there may have been deeper reasons for the neglect. The colonial worldview of the time often portrayed indigenous societies as simple and technologically limited. According to this view, advanced architecture and complex engineering were believed to arrive only with influence from India, China, or Europe. A massive, sophisticated stone structure built by ancient local people did not fit this narrative. Acknowledging such a site would have challenged the idea that colonial powers were bringing civilization to a primitive land. There was also the political dimension. By the early 20th century, nationalist movements were beginning to stir across the colonies. Indonesians were starting to question foreign rule and to search for symbols of their own identity and pride. A monumental ancient structure, clearly built by ancestors of the local population, could have become a powerful symbol. It would have provided physical proof that the land held a deep and advanced history long before European arrival. Such a discovery might have fueled resistance, pride, and unity. Seen in this light, the neglect of Gunung Padang may not have been entirely accidental. It is possible that allowing the site to fade into obscurity was a quiet form of suppression. By not drawing attention to it, colonial authorities avoided opening uncomfortable questions about history, capability, and ownership of the past. Whether deliberate or not, the result was the same. The mountain kept its secrets. Time passed. Empires weakened. The world changed. Indonesia eventually gained independence, shaking off centuries of colonial rule. With independence came a renewed interest in cultural identity. The past was no longer something filtered through foreign eyes. It became something to be reclaimed, re-examined, and understood on its own terms. It was in this new era that Gunung Padang re-emerged into the national consciousness. Local farmers, working the land near the hill, began to notice unusual stone formations. As they cleared vegetation and moved soil, they uncovered aligned columns and flat surfaces that clearly did not belong to nature alone. These were not random finds. The scale of what lay beneath the earth was impossible to ignore. The farmers sensed that they had stumbled upon something important, something connected to the stories they'd heard since childhood. They reported their discovery to local authorities. This time, the response was different. Indonesia was no longer a colony. It was a nation eager to understand its roots. The government's Bureau of Archaeology sent teams to investigate the site. What they found exceeded even Crom's early observations. Careful surveys revealed not 1 or 2 terraces, but 5 distinct levels climbing the hill. Across these terraces, researchers documented more than 400 stone structures. The stones were not placed randomly. Many showed consistent orientation, suggesting intentional alignment. Some appeared to line up with astronomical events, hinting at an ancient understanding of the sky. This was not merely a pile of stones. It was a carefully planned complex. The rediscovery of Gunung Padang was a powerful moment. Folklore and archaeology, often treated as separate worlds, suddenly overlapped. The legend of King Siliwangi's unfinished palace could now be seen in a new light. While the story itself may not be literal, it preserved the memory of a monumental construction project that had once dominated the landscape. Yet even as excitement grew, caution remained. The first official dating placed the site at around 2,500 years old. This made it ancient, but not revolutionary. It fit comfortably within accepted ideas of human development in the region. According to this timeline, Gunung Padang was impressive, but not extraordinary enough to force a rewriting of history. Still, something did not sit right. The scale of the construction, the effort required to quarry, transport and arrange so many massive basalt columns, suggested a level of organisation and knowledge that seemed older than the proposed date. The depth of the terraces, some buried beneath layers of soil, hinted at long periods of construction and use. The legend spoke of deep time, not recent history. The mountain itself seemed to resist simple explanations. Gunung Padang had revealed part of its story, but not all of it. Its surface spoke of human hands and ancient purpose, but its core remained unexplored. Beneath the visible terraces lay deeper layers of stone, soil and memory. To reach them would require not only excavation, but new questions and new tools. To truly understand the mystery of Gunung Padang, a person must imagine more than a visit. It is not a place that reveals itself easily to someone who simply looks and leaves. It demands to be felt, climbed, breathed in, and slowly absorbed. To walk upon its ground is to step into a conversation with deep time itself. You do not arrive as a tourist. You arrive as a pilgrim, climbing upward, step by step, leaving the modern world behind with every careful movement of your feet. The land changes the way you think before it changes what you see. The slope beneath you is not just earth and stone. It carries a weight of intention, as though countless hands once pressed purpose into every inch of it. At first glance, from a distance, Gunung Padang may appear to be nothing more than a forested hill, rising quietly above the surrounding countryside. Dense greenery covers its sides and mist often drapes itself over the summit in the early morning. But this first impression is deeply misleading. As you approach closer, the illusion of a natural hill begins to fall away. The ground becomes more structured. The stones begin to appear too evenly placed, too carefully aligned. This is not nature acting alone. This is nature guided, shaped, and transformed by human will on a scale that feels almost impossible to accept. This is not a simple hill decorated with scattered rocks. It is a monumental work of architecture, vast in size and breathtaking in ambition. The entire complex spreads across an area greater than 150,000 square meters, a space larger than many modern sports arenas where tens of thousands gather today. And yet this immense site was shaped without machines, without engines, without metal tools as we know them, and without the mechanical advantages that modern builders take for granted. The mind struggles to reconcile what the eyes clearly see. One of the most remarkable aspects of Gunung Padang is how seamlessly it blends human design with the natural landscape. Rather than flattening the land or carving a structure from scratch, the builders chose an extinct volcanic plug as their foundation. This ancient core of hardened magma already stood strong and tall, a natural pillar rising above the plains. Instead of fighting against it, they embraced it. They used its height, strength, and durability as the base for something even greater. In doing so, they turned a feature of the earth into a sacred pedestal for human vision. This choice alone speaks of deep understanding, not only of stone and structure, but of the land itself. The journey truly begins at the base of the site, where the first and largest of the visible terraces opens before you. This lower level feels like an invitation, and a warning at the same time. It welcomes you into the space, but it also announces the seriousness of what lies ahead. Hundreds of tall stone columns stand arranged in patterns that are far too orderly to be accidental. Some of these stones rise as tall as a grown man. Others lie horizontally, forming boundaries, walkways, and enclosed spaces. Many of them weigh as much as 300 kilograms, yet they were moved, lifted, and placed with care. These stones form what appear to be ritual enclosures, open courtyards, and carefully defined paths. Walking among them feels like moving through the remains of a forgotten language, one written not in words but in stone. Each placement seems deliberate, each alignment suggests meaning. There is a rhythm to the layout, a sense that movement through the space was guided, perhaps even choreographed. One can imagine gatherings here, ceremonies, processions, or moments of silent reflection shared by many people at once. The stones themselves are wonders of geology. They are made of volcanic andesite and basalt, born deep within the Earth's fiery interior. Long ago, molten rock cooled slowly, forming natural columns with 6 sides, almost as if shaped by a careful hand. This hexagonal form is a known feature of volcanic stone, yet seeing so many of these columns gathered together creates an unsettling feeling. Nature provided the raw material, but human intelligence recognized its potential and transformed it into something far greater. These stones were not simply collected from where they fell. Many were quarried, moved from their original locations and transported across uneven ground. Then they were raised upright or laid flat with astonishing accuracy. The effort required to accomplish this cannot be overstated. Without wheeled vehicles, without large domesticated animals to pull heavy loads, and without metal tools, the builders relied on methods that demanded careful planning, coordination, and cooperation among many people. This alone suggests a society that was not scattered or primitive, but organized, disciplined, and united by a shared purpose. From this broad and open lower terrace, your attention is naturally drawn toward the center of the site, where a grand staircase begins its ascent. This is not a narrow footpath worn down by chance. It is a formal and imposing structure, a central spine that runs straight through the heart of Gunung Padang. It is made up of roughly 370 steps, each one carefully shaped and placed. The staircase is wide enough for groups of people to walk side by side, suggesting that ascents were communal events rather than solitary journeys. As you begin to climb, the walls on either side of the staircase reveal another layer of mastery. These retaining walls have stood firm against thousands of years of heavy rain, earthquakes, and the slow pressure of the earth itself. In a tropical environment where moisture and plant growth destroy most ancient structures, this endurance feels almost miraculous. Yet it is not magic. It is engineering, guided by knowledge passed down through generations. With every step upward, something changes. The sounds of birds and insects soften. The distant noises of villages and roads fade away. The air becomes cooler and thinner, carrying with it a strange stillness. Many visitors and local guides speak of a subtle sensation that emerges as they climb. Some describe it as a gentle vibration underfoot. Others speak of a low humming sound, barely audible, but felt more than heard. Whether this is a physical resonance caused by the stone and the shape of the structure, or something perceived through the power of suggestion, it adds to the sense that this place is alive in a way that defies simple explanation. As you rise higher, the terraces become smaller and more focused. Each level narrows compared to the one below it, creating the unmistakable shape of a stepped pyramid. This design is not unique to Gunung Padang. Similar forms appear in ancient cultures across the world, separated by oceans and thousands of years. The sacred mountains of Mesopotamia, the towering pyramids of central Mexico, and the ancient ceremonial cities of South America all share this rising tiered structure. The resemblance is striking and deeply unsettling. How could such similar ideas appear in places so distant from one another? Standing on one of the higher terraces, you gain a commanding view of the surrounding landscape. Valleys stretch outward, framed by distant volcanoes that still loom as reminders of the Earth's restless power. The sky feels closer here, wider, and more open. It is easy to imagine this place as a point of connection between worlds, where Earth meets sky, and humanity reaches towards something greater than itself. At the uppermost level, the feeling of culmination is undeniable. This is not a place designed for crowds or casual movement. It feels reserved, focused, and intensely symbolic. One can imagine a spiritual leader standing here gazing upward, performing rituals meant to align the community with the rhythms of the cosmos. Or perhaps a ruler stood here, surveying the land, drawing authority not just from power, but from proximity to the sacred. Surrounded by ancient stones and endless sky, awe becomes overwhelming. The questions rise uninvited and refuse to be silenced. How did the people who built this place accomplish such a feat? According to traditional views of human history, societies at such an early stage should not have possessed the knowledge or organization required for construction on this scale. Moving massive stones up an incline nearly 90 meters high, placing them with precision, and shaping the land itself into a monumental form demands planning, leadership, and advanced problem-solving skills. One possibility is that the builders used massive earth ramps, gradually raising the stones higher as construction progressed. Others suggest intricate systems of wooden rollers, levers and ropes made from plant fibers. These methods are simple in concept but incredibly demanding in execution. They require large numbers of people working together in perfect coordination, trusting one another, and following shared instructions. Such cooperation points to a complex social structure, one capable of sustaining long-term projects that may have taken generations to complete. Yet there are those who believe even these explanations fall short. Some propose that the builders possessed knowledge that has since been lost, techniques that allowed them to reduce the weight of stone or manipulate sound and vibration to make lifting easier. While these ideas remain controversial and lack direct evidence, they persist because Gunung Padang itself challenges the boundaries of what we think ancient people could achieve. Every terrace, every carefully aligned stone, every enduring wall stands as a quiet challenge to modern assumptions. This site does not shout its secrets. It whispers them through stone and silence, daring us to listen more closely. It reminds us that history is not a straight line of simple progress from ignorance to knowledge. It is a tangled path filled with forgotten brilliance, lost wisdom, and achievements that still refuse to fit neatly into our timelines. Walking back down from the summit, the experience lingers. The stones seem to watch in silence as you leave, unchanged by your presence, yet somehow altered by your understanding. Gunung Padang is not just an archaeological site, it is a question made of earth and stone, one that continues to endure through rain, time, and human doubt. It stands as a reminder that the past may be far more complex, creative, and mysterious than we are comfortable admitting. For many long decades, the story of Gunung Padang seemed almost simple, at least on the surface. Visitors climbed its slopes, stepped across its stone paths, and stood on its broad terraces while scholars carefully measured, photographed, and debated what they could see with their own eyes. The hill appeared ancient and important, but not impossible to understand. 5 wide terraces rose one above the other, built from dark volcanic stone columns arranged in deliberate patterns. These terraces felt ceremonial, like stairways meant to guide the human spirit upward toward the sky. Archaeologists believed that with enough patience, enough digging, and enough careful comparison to other known sites, they would one day explain who built them, when they were built, and why. For a long time, the mystery of Gunung Padang seemed locked safely on the surface, waiting calmly for human hands to uncover it piece by piece. Yet this sense of control was an illusion. Beneath the visible stones, beneath the moss and soil and roots of the jungle, something far greater was hidden. The true transformation in understanding Gunung Padang did not come from brushes gently sweeping dirt, away from stones, or from trenches carved slowly into the earth. Instead, it came from machines that could see without touching, from instruments that allowed scientists to peer into the body of the hill itself. These tools peeled back the skin of the mountain and revealed that Gunung Padang was not merely a hill with ancient decorations on top. It was something closer to a vast puzzle box, a layered construction, a labyrinth whose corridors and chambers were sealed by time. At that moment, a local curiosity began its journey toward becoming one of the most unsettling archaeological enigmas in the world. This turning point arrived when an Indonesian research team, led by geologist Danny Hilman Natawijaja, brought a powerful collection of non-invasive geophysical technologies to the site. These tools did not break the ground or disturb the stones. Instead, they acted like new senses for the human body, senses capable of seeing through earth and rock. Each method worked in a different way, much like sight, hearing, and touch offer different kinds of information about the world around us. Together, they allowed the scientists to listen to the hill, to feel its internal structure, and to glimpse shapes buried deep within it. One of the most important tools they used was ground-penetrating radar. This technology sends short bursts of electromagnetic energy into the ground. When these signals move through uniform soil or solid rock, they pass quietly and leave little trace. But when they strike something different, such as a buried wall, a cavity, or a layer of material unlike its surroundings, the signals bounce back. By measuring these reflections, scientists can build an image of what lies below the surface. In simple terms, ground-penetrating radar works much like a medical scan of the human body, allowing doctors to see bones and organs hidden beneath skin and muscle. At Gunung Padang, it allowed researchers to see the outlines of structures that no human eye had looked upon for tens of thousands of years. Alongside this, the team used electrical resistivity tomography. This method involves sending small electrical currents into the ground through metal probes. Different materials resist electricity in different ways. Natural soil, compacted stone, loose rubble, and empty spaces all respond differently to electrical flow. By carefully measuring these differences, scientists can create a three-dimensional picture of what lies underground. It is like mapping the invisible by listening to how the Earth answers back. In places where the resistance changed sharply and suddenly, the researchers suspected artificial structures rather than natural formations. The third major tool was seismic tomography. This technique creates small, controlled vibrations in the ground, almost like tiny earthquakes. Sensors then measure how quickly sound waves travel through the hill. Dense rock carries these waves quickly, while empty spaces and loose materials slow them down. By tracking these changes, scientists can create a sonic map of the interior of the hill. It is as though the mountain itself is speaking, revealing where it is solid and where it is hollow. Used together, these methods formed a powerful system of underground vision, capable of revealing secrets hidden far beyond the reach of traditional archaeology. What these technologies revealed was deeply unsettling. The image that emerged did not match the idea of a natural volcanic hill with a few ancient stone arrangements placed on top. Instead, the data suggested a massive layered construction that extended deep into the earth. The visible terraces were only the outermost skin of a far larger and older creation. The scientists began to divide what they saw into distinct units, each representing a different phase of construction and use. The uppermost layer, known as Unit 1, matched what archaeologists had already studied for years. It consisted of loosely stacked stone columns arranged into terraces and pathways. These stones appeared to have been placed deliberately, but without the tight packing or deep foundations seen in more complex structures. Based on earlier studies, this layer was believed to date to a time between roughly 1,500 and 2,500 years ago. This placed it within a period of human history when organized societies, agriculture, and ceremonial architecture were already well established in many parts of the world. In other words, Unit 1 was ancient, but not impossible to explain. But as the digital probes looked deeper, a second layer emerged, and with it came a shock. At depths ranging from roughly 3 to 5 meters below the surface, the scans revealed Unit 2. This layer was far more compact and orderly than the one above it. The rocks were tightly packed, and the soil appeared to have been intentionally placed rather than naturally accumulated. This was not the chaotic rubble of a landslide or the random deposits of volcanic activity. It looked like deliberate fill, carefully arranged to support something above it. To better understand this layer, the scientists extracted core samples. These were long, narrow cylinders of earth pulled from deep within the hill. Each core was like a timeline, preserving layers of soil and stone in the order they were laid down. Within these samples, researchers found small flecks of charcoal and bits of organic material. These tiny fragments were incredibly important, because they could be dated using radiocarbon analysis. This method measures the slow decay of carbon in once living material, allowing scientists to estimate how long ago it was formed. When the results came back, they defied belief. The dates did not place Unit 2 in the era of early farming societies, or even in the dawn of agriculture. Instead, they clustered in a range between approximately 16,000 and an astonishing 28,000 years before the present. This period belonged to the Upper Paleolithic, a time when much of the world was locked in the grip of the last ice age. According to traditional models of human history, people of this era lived as small bands of hunter-gatherers. They were believed to lack the social organization, technological skills, and surplus resources needed to build large, complex stone structures. Yet here was evidence suggesting that such a structure existed. The implications were staggering. If these dates were correct, then Gunung Padang was not merely older than Stonehenge or the pyramids of Egypt. It was older by tens of thousands of years. It came from a time when vast ice sheets covered large portions of the northern continents, when sea levels were far lower than today, and when human societies were thought to be simple and mobile. The data seemed to describe a civilization that should not exist, a ghost rising from the depths of prehistory to challenge everything we thought we knew. The surprises did not end there. The scans also revealed voids within Unit 2. These empty spaces appeared to form chambers or tunnels extending into the hillside. Their shapes were one of the most troubling aspects of the discovery. Natural volcanic features, such as lava tubes, tend to have irregular forms, with curved walls and unpredictable paths. Erosion cavities carved by water are similarly uneven and chaotic. But the voids beneath Gunung Padang showed symmetry. Their corners appeared sharp, their outlines clean and deliberate. These were not the messy creations of nature, they looked designed. As researchers pushed their investigations even deeper, they encountered hints of yet another layer. At depths exceeding roughly 20 meters below the surface, the scan suggested the presence of a fourth unit, a foundational core made of fractured bedrock. Even this deepest layer appeared to show signs of modification, as though the natural rock had been shaped and altered by human hands. If true, this meant that the builders of Gunung Padang did not simply pile stones on top of a hill. They reshaped the hill itself, carving and reinforcing its core as part of a grand architectural plan. The emerging picture was that of a palimpsest, a site written over again and again across immense spans of time. Each generation appeared to honour what came before, adding new layers, new meanings, and new structures without erasing the ancient heart of the place. The visible terraces were not the beginning of the story. They were the latest chapter in a narrative that stretched back into the depths of the Ice Age. This idea transformed Gunung Padang from a single monument into a living tradition, a sacred mountain continually renewed by human hands across countless generations. The size of the hidden chambers added yet another layer of mystery. Some of the voids detected by the scans appeared to measure roughly 10 by 15 meters, spaces large enough to hold gatherings of people. What could such chambers have been used for? The possibilities sparked intense debate. Some researchers wondered if they were tombs, places where important individuals were laid to rest in honour and reverence. Others suggested ritual spaces, underground sanctuaries where ceremonies were conducted away from the surface world. There were even theories that these chambers might have been designed with sound in mind. Gunung Padang is known for its unusual acoustic properties. Sounds made on certain terraces can echo and resonate in unexpected ways. Some researchers believe that the underground chambers could have acted as resonant echo spaces, amplifying chants, drums, or other ritual sounds. In a world without written language, sound would have been a powerful tool for shaping emotion, memory, and belief. These chambers might have been designed to produce experiences that felt magical or otherworldly, reinforcing the sacred nature of the site. All of this raised an even larger question. Who were the people capable of such achievements? If the radiocarbon dates were correct, these builders lived during a time when humans were believed to be scattered and technologically limited. Yet the evidence from Gunung Padang suggested planning, engineering skill, and a deep understanding of stone and landscape. It suggested long-term thinking, knowledge passed down through generations, and a shared vision powerful enough to motivate immense labour. The data streaming from the machines did not merely add details to an existing story, it rewrote the story entirely. It suggested that advanced cultural behaviour might have emerged far earlier than previously thought, only to be lost or forgotten as climates changed and societies shifted. The end of the last ice age brought dramatic environmental upheaval. Rising seas swallowed coastal lands. Changing rainfall patterns transformed forests and grasslands. It is not difficult to imagine how entire ways of life, entire knowledge systems, could have vanished under such pressures, leaving behind only stone and silence. In this sense, Gunung Padang began to feel less like a single site, and more like a message from a forgotten chapter of human history. It hinted that our ancestors may have been more capable, more creative, and more organised than we have allowed ourselves to believe. It suggested that the story of civilization is not a straight line from simplicity to complexity, but a winding path with lost peaks and hidden valleys. Of course, such claims are controversial. Many scholars urge caution, pointing out the need for further verification and independent studies. Extraordinary claims, they argue, require extraordinary evidence. Yet even skeptics acknowledge that the data from Gunung Padang cannot be easily dismissed. The consistency of the findings across different methods, the clear patterns revealed by the scans, and the repeated radiocarbon dates all demand serious consideration. What makes Gunung Padang so compelling is not just its age or its size, but the way it forces us to confront our assumptions. For a long time, archaeology has been guided by a model in which complex societies emerge only after certain conditions are met, such as agriculture and permanent settlements. Gunung Padang challenges this model by suggesting that large-scale construction and sophisticated planning may have occurred among peoples we once considered incapable of such feats. Standing on the terraces today, one cannot help but feel the weight of this realization. The stones beneath your feet are not merely old, they are witnesses to a deep and mysterious past, a past that stretches far beyond recorded history. Beneath them lie layers upon layers of human effort, memory and belief, sealed away in darkness for thousands of years. The hill no longer feels like a simple monument. It feels like a living archive, a stone library whose pages are only now being slowly opened. As technology continues to advance, the story of Gunung Padang will likely grow even more complex. New tools may reveal details we cannot yet imagine. Perhaps future excavations, conducted with care and respect, will uncover artifacts that shed light on the lives of its builders. Perhaps the hidden chambers will one day be entered, revealing their purpose at last. Or perhaps Gunung Padang will remain partially silent, guarding some of its secrets forever. What is certain is that the hill has already changed the conversation. It has transformed from a local wonder into a global enigma, from a set of terraces into a symbol of humanity's forgotten potential. It reminds us that the past is not fixed, that our understanding of it can be overturned by a single discovery. And it invites us to approach ancient sites not with arrogance, but with humility, ready to accept that our ancestors may have known far more than we once believed. At the heart of the long, emotional and often turbulent story of Gunung Padang stands one man whose personal journey mirrors the mystery of the site itself. His name is Dr. Danny Hilman Natuiji, often also referred to in public discussions as Dr. Natawi Jaja. To truly understand why Gunung Padang has become one of the most debated archaeological locations on Earth, one must first understand this man, his background, his mindset, and the quiet but powerful transformation that changed the course of his career. This is not simply a story about stones stacked on a hill. It is a story about how a disciplined scientist trained to read the language of the planet itself found himself confronting questions that reached far beyond geology and deep into humanity's forgotten past. Dr. Natawi Jaja did not begin his professional life searching for lost civilizations or legendary structures whispered about in ancient stories. His world was one of measurements, graphs, seismic readings, and the relentless movement of tectonic plates. As a senior geologist at Indonesia's National Research and Innovation Agency, his daily work focused on understanding earthquakes, volcanic systems, and the massive forces that constantly reshape the earth beneath our feet. These were not romantic subjects. They were urgent, practical, and often terrifying realities for a nation that sits along some of the most active fault lines on the planet. His research dealt with sudden ruptures in the Earth's crust, with stresses building invisibly for centuries before releasing their energy in seconds of devastation. Entire cities could rise or fall based on the patterns he studied. This background matters deeply because it shaped the way he saw the world. Dr. Natawi Jaja was not a man inclined toward fantasy. He trusted data. He trusted instruments. He trusted repeatable measurements and physical evidence. His understanding of the Earth was rooted in processes that were immense, slow, violent, and indifferent to human belief. Volcanoes did not care about legends. Fault lines did not respond to myth. They followed physical laws that could be studied, modelled, and to a degree predicted. This mindset made him an unlikely figure to later become associated with one of the most controversial historical claims of modern times. When Dr. Natawi Jaja first encountered Gunung Padang in the early years of the 21st century, his interest was purely geological. At that time, Gunung Padang was widely known as an ancient megalithic site, a place of cultural importance where stone columns lay scattered across terraced slopes. Archaeologists had studied it for decades, and while it was considered impressive, it was not viewed as revolutionary. The hill was believed to be a natural volcanic formation that had been modified by ancient people who arranged stones on its surface for ceremonial purposes. In this view, the hill itself was nature's work, while human hands merely shaped what was already there. Dr. Natawi Jaja approached the site with this same assumption. He was not searching for a lost palace or an Ice Age monument. He was studying the hill as a geological structure. He examined its layers, its rock composition, and its internal consistency, expecting to find the chaotic patterns typical of volcanic activity. Volcanoes, after all, do not build with symmetry or intention. They erupt, collapse, fracture, and leave behind disorder shaped by gravity, pressure, and chance. Yet as he observed Gunung Padang more closely, something began to disturb him. The terraces that wrapped around the hill were not random. They rose in deliberate steps, wide and level, one above another. The stone columns, known as columnar joints, were arranged with a consistency that felt purposeful rather than accidental. Instead of the messy distribution expected from a collapsed volcanic dome, there was organization. There was repetition. There was balance. To a trained geologist, these features did not sit comfortably within the framework of a purely natural formation. This discomfort did not arrive as a dramatic revelation. It grew slowly, like a quiet voice that refuses to be ignored. Each measurement, each scan, each careful observation added to the sense that something about Gunung Padang did not fit. Dr. Natawi Jaja began to feel that he was not just looking at a hill, shaped by fire and time, but at something that had been touched, altered, and perhaps constructed with intent. The stones seemed to tell a different story when viewed through the lens of geology rather than traditional archaeology. Local legends began to take on new meaning in his mind. Stories passed down for generations spoke of a palace built in a single night, a structure raised by ancient powers beyond normal human ability. For years, these tales had been dismissed as folklore, symbolic stories meant to inspire or warn rather than inform. But to Dr. Natawi Jaja, they started to sound less like pure invention and more like echoes of something real, distorted by time but rooted in memory. He did not suddenly believe the legends as literal truth, but he began to wonder if they preserved a cultural memory of construction so ancient and so misunderstood that it had slipped into myth. This shift in perspective marked a turning point in his life. He moved from studying fault lines in the earth to investigating what could be described as a fault line in human history. The questions he began to ask were no longer limited to geology. They crossed into archaeology, anthropology, and the deep timeline of human development. Who were the people who first shaped Gunung Padang? When did they live? What level of knowledge did they possess? And why did the structure beneath the hill appear so complex? Recognizing that such questions could not be answered by one discipline alone, Dr. Natawi Jaja sought help. With initial support from the Indonesian government during the presidency of Susilo Bambang Yudhoyono, who recognized the potential importance of the site for national heritage, he assembled a diverse team of experts. Geophysicists brought tools capable of peering beneath the surface without digging. Archaeologists offered insight into human patterns of construction and ritual. Soil experts analysed sediment layers. Paleontologists helped establish environmental context from deep time. This was not a small or casual effort. It was a coordinated attempt to apply the full power of modern science to a mystery that had slept beneath jungle and stone for thousands of years. As their instruments began to probe the interior of Gunung Padang, the results were startling. Beneath the visible terraces lay additional layers, stacked and structured in ways that suggested deliberate construction. The hill was not solid rock, but a complex arrangement of materials. Radiocarbon dating of organic matter trapped between layers produced dates that pushed far back into the past, far earlier than conventional timelines for large-scale stone construction. Each new result added weight to a hypothesis that would soon shake the foundations of accepted history. Dr. Natawi Jaja began to suggest that Gunung Padang was not merely a surface site, but a multi-layered structure, possibly a pyramid concealed beneath earth and vegetation. At its core, he proposed, lay a construction that dated back to the last ice age, a time when humans were believed to live as simple hunter-gatherers. If true, this would mean that organised, large-scale building existed tens of thousands of years earlier than mainstream archaeology allowed. This idea was not introduced lightly. Dr. Natawi Jaja understood its implications. It challenged the widely accepted narrative of human development, which holds that complex societies arose only after the end of the Ice Age, when agriculture allowed people to settle, specialise and build. A pyramid from such a distant time would suggest that our ancestors were far more capable, organised, and knowledgeable than previously believed. As the public face of this theory, Dr. Natawi Jaja found himself thrust into the spotlight. He gave interviews, delivered lectures, and presented data to audiences both supportive and hostile. To some, he was a visionary scientist brave enough to follow evidence wherever it led. To others, he became a symbol of dangerous speculation, someone blurring the line between science and myth. Critics argued that his interpretations went beyond what the data could firmly support. They warned against rewriting history based on incomplete evidence. The tension between Dr. Natawi Jaja and the established archaeological community grew intense. Archaeologists trained to interpret human behaviour through artefacts, settlements, and cultural patterns were wary of conclusions drawn primarily from geological data. From their perspective, extraordinary claims required extraordinary proof, and they questioned whether the evidence truly justified such a radical shift in chronology. To them, the idea of an Ice Age pyramid felt less like a discovery and more like a threat to decades of carefully built scholarship. Dr. Natawi Jaja found himself cast in an uncomfortable role. He was labelled a heretic, a challenger to orthodoxy. Yet he did not see himself that way. In his mind, he was not attacking history, but expanding it. He believed that science must remain open to revision when new evidence appears. The Earth, after all, does not lie. Instruments do not invent patterns. If the data suggested something extraordinary, then it was the duty of scientists to investigate, not dismiss. His persistence came at a personal cost. Professional criticism can be isolating, especially when it comes from peers whose respect one values. Yet Dr. Natawi Jaja continued his work, driven by the quiet conviction that he was following the truth as best he could see it. He remained grounded in his identity as a geologist, a man trained to listen to what the planet itself reveals through layers of stone and time. What makes his journey so compelling is that it is not fueled by ego or spectacle, but by curiosity and responsibility. Indonesia is a land shaped by deep time, by volcanic forces and ancient cultures layered upon one another. To uncover a hidden chapter of that story is not merely an academic exercise, it is an act of cultural remembrance. If Gunung Padang truly represents a monument left behind by Ice Age humans, then it speaks to a forgotten chapter of human ingenuity, resilience, and imagination. Even if future research modifies or challenges Dr. Natawi Jaja's conclusions, his impact cannot be erased. He reopened questions that many believed were settled. He reminded the world that history is not a closed book, and that beneath the ground we walk on may lie stories far older and stranger than we expect. His transition from studying the Earth's restless movements to exploring humanity's deepest roots forms the emotional and intellectual core of the Gunung Padang saga. What should have been a proud and celebratory moment in the world of archaeology instead became the spark that ignited one of the fiercest academic battles of the modern age. When the research led by Dr. Natawi Jaja was finally published in the respected peer-reviewed journal Archaeological Perspection in the month of October in the year 2023, it appeared at first glance to be the natural reward for many long years of slow, exhausting, and highly detailed work. This paper was not rushed, it was not casual. It represented the careful gathering of geophysical survey results, the drilling and analysis of deep core samples, and the interpretation of radiocarbon dates that were so unexpected and so unsettling that they pointed toward an origin for Gunung Padang, reaching back into the last ice age itself. Such a conclusion, if proven correct, would force scholars to rethink nearly everything they believed about when complex human construction first began. Under normal circumstances, the publication of such a paper would have been greeted with excitement, curiosity, and cautious debate. It should have opened the door to further study, deeper investigation, and perhaps even international collaboration. Instead, the moment the paper entered the public academic record, it acted like a lit match dropped into dry grass. Rather than applause, it triggered shockwaves. Quiet at first, these tremors spread rapidly through universities, research institutions, and archaeological departments across the world. Behind closed doors and eventually in public forums, a fierce backlash began to build, growing in speed and intensity until it could no longer be ignored. By the month of March in the year 2024, events took a turn that stunned many observers both inside and outside the academic community. In a move that few had anticipated, Archaeological Perspection officially withdrew or retracted Dr. Natawi Jaja's paper. Retractions are rare, especially for work that has already passed through peer review. When they do happen, they're usually associated with clear cases of fraud, plagiarism, or undeniable methodological errors. This made the decision all the more shocking. According to the official statement released by the journal's editors, the reason for the retraction was a major error at the heart of the research. The editors, supported by a growing chorus of critics, argued that Dr. Nadawa Jaja and his team had fundamentally misunderstood their own data. They claimed that while the data itself might be real, the interpretation of that data was deeply flawed. At the centre of this criticism was the issue of radiocarbon dating. The team had dated ancient organic material found deep within the structure of Gunung Padang and had concluded that these dates reflected phases of human construction far older than anything previously accepted. However, critics insisted that this leap was unjustified. One of the most frequently cited examples involved charcoal fragments discovered roughly 15 metres below the surface. Dr. Nadawa Jaja's team saw these fragments as possible evidence of human activity, perhaps remnants of ancient fires associated with construction or habitation. The critics, however, offered a far more conservative explanation. They argue that charcoal at such a depth does not automatically indicate human presence. According to them, ancient natural wildfires could easily have produced charcoal long before humans ever touched the site. Over thousands of years, that charcoal could have been carried downward by natural processes. The same argument was applied to the other organic sediments that had been dated. Skeptics suggested that groundwater movement could have washed organic material into deeper layers. Burrowing animals, over countless generations, might have dragged plant matter downward. Tree roots, growing and dying again and again across millennia, could have penetrated deep into the soil, carrying organic material with them. From this perspective, the presence of ancient organic matter beneath the surface did not necessarily mean that humans were building anything at that time. This line of reasoning was summed up in a phrase repeated again and again by critics. You cannot date a building by dating the soil that surrounds or buries it. In their view, the dates obtained by Dr. Nadawa Jaja's team reflected the age of the natural environment, not the age of human construction. To them, the conclusion that Gunung Padang had an Ice Age origin was not just unsupported but misleading. As the debate grew louder, prominent archaeologists from many different countries stepped forward to voice their agreement with the retraction. These were not fringe figures. They were well-known scholars with long careers and respected reputations. Many of them also targeted the geophysical scans that Dr. Nadawa Jaja's team had presented as evidence of hidden chambers and artificial structures deep within the hill. According to these critics, such scans are notoriously difficult to interpret. What one researcher sees as a man-made void, another might see as a natural feature. They suggested that the shapes identified by the scans could simply be the result of volcanic processes, such as lava tubes formed when molten rock flowed and later cooled. Others argued that erosion, fracturing, and the natural layering of volcanic stone could easily produce patterns that appear symmetrical or rectangular when viewed through geophysical instruments. Without direct excavation and undeniable artifacts, they argued, such interpretations remained speculative at best. Another major point raised by critics was the absence of what they considered definitive signs of human activity in the deepest layers. There were no clearly identifiable stone tools, no pottery fragments, no human bones, no carvings or inscriptions. In traditional archaeology, such artifacts serve as unmistakable markers of human presence. Their absence, especially at depths supposedly dating back tens of thousands of years, was seen as a serious weakness in the argument. All of these objections were ultimately condensed into a single, powerful principle that has guided scientific thinking for generations. Borrowing from a famous saying often attributed to Carl Sagan, critics repeated the idea that extraordinary claims require extraordinary evidence. To suggest that humans were constructing massive stone monuments during the Ice Age was, in their view, an extraordinary claim indeed. And to them, the evidence presented simply did not meet that high standard. From the perspective of the mainstream archaeological community, the case was clear. The retraction was justified. The conclusions were premature. The risks of misleading the public and distorting the scientific record were too great to ignore. As far as they were concerned, the matter should have ended there. But for Dr. Nadawa Jaja and his team, the story was far from over. They responded to the retraction with force, passion, and determination. Publicly and privately, they challenged the decision arguing that it was not only unfair but deeply flawed. In their view, the critics had fixated on one aspect of the evidence while ignoring the broader picture. They acknowledged that radiocarbon dating alone cannot prove human construction. However, they insisted that their argument did not rest on carbon dates in isolation. Instead, they pointed to the geophysical evidence as the true backbone of their case. According to them, the shapes detected beneath Gunung Padang were not random. They were not chaotic. They showed symmetry, alignment, and angular forms that strongly suggested intentional design. Rectangular voids, they argued, are extremely rare in natural geological settings, especially at multiple depths and orientations. No natural processes, they claimed, do not produce such consistent geometry on such a scale. To dismiss these features as mere volcanic quirks, they said, was to ignore basic principles of geology. Dr. Nadawa Jaja and his supporters also took issue with what they perceived as double standard. They argued that many accepted archaeological sites around the world are interpreted with far less evidence than what they had presented at Gunung Padang. In those cases, geophysical scans, contextual clues, and indirect indicators are often considered sufficient to justify further exploration. Why, they asked, was Gunung Padang being held to a higher bar? As the debate intensified, the language used by Dr. Nadawa Jaja's team grew sharper. They described the retraction as an act of academic gatekeeping, a defensive maneuver by an establishment unwilling to consider ideas that threatened long-standing narratives. According to this view, archaeology, like any human institution, is shaped by power structures, traditions, and deeply rooted assumptions. Ideas that challenge those foundations are often resisted, not because they are wrong, but because they are uncomfortable. Adding fuel to the fire was the broader political context surrounding the site. Gunung Padang is located far from the traditional centres of what is often called civilization in mainstream history books. For centuries, the story of advanced ancient societies has focused heavily on regions like the Middle East, Europe, and parts of the Mediterranean. A discovery suggesting that monumental construction began much earlier and in Southeast Asia would dramatically shift that narrative. This possibility gave rise to darker suspicions among supporters of Dr. Nadawa Jaja. They began to wonder whether the resistance to his work was purely scientific, or whether it was influenced by cultural and geopolitical bias. Was it merely a coincidence, they asked, that the project faced such intense opposition just as it was attracting global attention? Or were there powerful interests both within the country and beyond it who felt threatened by the implications of the research? The retraction in the year 2024 did not silence these questions. Instead, it amplified them. What had once been a technical disagreement about data interpretation began to take on a more philosophical tone. The debate was no longer just about dates, sediments, or scan images. It became a conversation about who has the authority to define the past. For many supporters, Dr. Nadawa Jaja was transformed into a symbol. They compared him to historical figures like Galileo Galilei, who challenged accepted beliefs and paid a heavy price for doing so. In this narrative, Dr. Nadawa Jaja was a modern-day truth seeker, punished not for being wrong, but for daring to suggest that the story of human history might be far older and more complex than previously believed. For his critics, however, the comparison was deeply flawed. They saw Dr. Nadawa Jaja not as a martyr, but as a warning. In their view, science advances through caution, skepticism, and strict standards of proof. When researchers allow excitement or personal belief to outrun the evidence, they risk misleading both the academic community and the public. From this perspective, the retraction was not an act of suppression, but a necessary correction. As months passed, the controversy showed no sign of fading. Articles, interviews, online debates, and academic responses continued to appear. Each side accused the other of misunderstanding the evidence, of ignoring inconvenient facts, or of being driven by motives other than the search for truth. The name Gunung Padang became synonymous not just with an ancient site, but with one of the most intense scientific disputes of the modern era. What is undeniable is that the retraction did not bring closure. If anything, it ensured that the mystery would endure. Questions remain unanswered. Are the structures beneath Gunung Padang natural or artificial? If they are artificial, who built them, and when? If they are natural, why do they appear so ordered and symmetrical? And perhaps most importantly, how should science handle discoveries that challenge its deepest assumptions? The story of Gunung Padang now exists in a strange space between established knowledge and radical possibility. It sits at the intersection of hard data and human interpretation, of evidence and belief. Whether future research will vindicate Dr. Nada Wajaja or confirm the doubts of his critics remains to be seen. What is certain is that the events surrounding the publication and retraction of his paper have left a lasting mark. They have exposed the tensions that lie beneath the surface of scientific inquiry. They have shown how fragile consensus can be when confronted with ideas that threaten to rewrite history. And they have reminded the world that the past is not just something we discover in the ground, but something we argue over, defend, and sometimes fear. Beyond the grand theories, the heated arguments over timelines, and the endless debates that fill academic journals, the mystery of Gunung Padang ultimately rests on things that feel solid and real. These are not abstract ideas or distant speculations. They are physical objects and measurable phenomena, things that can be touched with bare hands, weighed, sampled, tested, and placed under microscopes. They are the stones underfoot, the strange substances hidden deep inside the hill, and the unusual behaviours that seem to defy what we believe should be possible for people living in the deep past. These tangible pieces of evidence give the mystery its true power, because they suggest that the builders of Gunung Padang were not merely strong workers stacking stones, but individuals with knowledge, skills, and understanding that look startlingly advanced even by modern standards. When you stand on the terraces of Gunung Padang and look at the massive basalt columns arranged with such care, it is easy to imagine countless hands hauling and positioning these stones through sheer effort and determination. But the deeper researchers dig, both literally and figuratively, the more it becomes clear that brute force alone cannot explain what lies beneath the surface. There is an intelligence embedded in the structure, a kind of quiet sophistication that reveals itself only when scientists begin to peel back the layers and examine what holds the monument together at its deepest levels. One of the most astonishing discoveries comes from core samples taken from what researchers call Unit 3, a deeply buried layer far below the visible terraces. According to radiocarbon dating, this layer may reach back as far as 28,000 years into the past. That date alone is enough to make many archaeologists uncomfortable, because it pushes the construction of complex architecture far beyond what conventional history allows. But the date is only the beginning of the shock. What truly challenges our understanding is the material found binding the basalt columns together in this ancient layer. At first glance, one might expect to find simple mud, compacted earth, or perhaps nothing at all between the stones. After all, according to standard views, people living tens of thousands of years ago were hunter-gatherers with limited technology. They are not supposed to have known how to make advanced building materials. Yet the samples taken from Gunung Padang tell a very different story. Instead of crude filler, researchers found a form of ancient cement, a carefully engineered substance that displays remarkable strength and durability. This was not accidental clay squeezed between stones by pressure over time. Chemical analysis revealed that the binder is a complex mixture of clay, silica, and iron oxides, combined in proportions that suggest deliberate design rather than chance. Even more surprising is the way this material behaves. It does not soften and crumble in the wet, humid conditions of the tropical environment. Instead, it hardens and becomes stronger, much like modern hydraulic cement. To create such a substance, the builders would have needed more than simple observation. They would have needed controlled firing at high temperatures, exceeding 800 degrees. This level of heat control implies the use of advanced kilns or furnaces, as well as an understanding of how different materials react when heated and combined. These are not skills normally attributed to people living tens of thousands of years ago. In fact, according to mainstream history, even the civilizations of ancient Egypt, with all their grandeur and sophistication, did not develop lime mortars until many millennia later. What makes this discovery even more astonishing is the comparison with Roman concrete, long celebrated as one of the greatest engineering achievements of the ancient world. Roman builders mastered the art of creating durable concrete that could withstand water, earthquakes, and the passage of centuries. Yet the cement found at Gunung Padang appears to predate Roman concrete by more than 20,000 years. This means that a technology we associate with one of history's most advanced ancient empires may have existed in some form long before Rome itself was even a distant idea. Some researchers have gone even further, comparing the ancient cement of Gunung Padang to modern geopolymers. Geopolymers are a relatively recent innovation, developed by scientists who study how natural rocks form over long periods of time. By mimicking these processes using alkaline liquids and sources of silicon and aluminum, modern engineers can create strong, durable materials with a smaller environmental footprint than traditional cement. To suggest that ancient builders may have stumbled upon a similar process is almost unthinkable, yet the chemical signatures in the Gunung Padang samples make this comparison difficult to ignore. If this interpretation is correct, it implies that the builders possessed a deep and almost intuitive understanding of geochemistry. They may not have written formulas or drawn diagrams, but they knew through careful experimentation how earth, fire, and minerals could be transformed into something far stronger than the sum of its parts. In this sense, they were not just builders. They were artisans and scientists, practitioners of a forgotten craft that balanced observation, experience, and knowledge passed down through generations. As if this were not enough to challenge our assumptions, laboratory analysis of the cement has revealed another unexpected property. The material appears to have piezoelectric qualities. In simple terms, this means it can generate a small electrical charge when subjected to mechanical stress. Even today, piezoelectric materials are used in devices like sensors, microphones, and quartz watches. They convert pressure or vibration into electrical signals, a principle that underlies much of modern technology. At Gunung Padang, this property becomes especially intriguing because the structure is constantly exposed to tiny vibrations. The earth is never completely still. Microtremors ripple through the ground day and night, caused by tectonic movements, distant earthquakes, and even the movement of water and wind. If the cement binding the stones responds to these stresses by generating electrical charges, then the entire monument may be subtly alive with energy, producing faint electrical activity as it interacts with the restless planet beneath it. This possibility leads directly to the second great physical mystery of Gunung Padang, its strange and powerful acoustics. Many visitors, including local mystics, casual tourists, and trained scientists, have all remarked on the unusual sounds associated with the site. Gunung Padang is not a quiet place in the way one might expect from an ancient ruin hidden among hills. Certain stones seem to hum, resonate, or respond in unexpected ways when touched or struck. When some of these stones are gently hit, they do not produce a dull, dead thud like ordinary rocks. Instead, they ring out with clear metallic tones that linger in the air far longer than expected. The sound is not harsh or chaotic. It is smooth, almost musical, as if the stone itself were a carefully crafted instrument rather than a random piece of volcanic rock. For a long time, such reports were dismissed as imagination or exaggeration. People visiting mysterious places often expect unusual experiences, and the human mind is very good at finding patterns where none exist. However, scientific testing has shown that something genuinely unusual is happening at Gunung Padang. Using sensitive accelerometers and other measuring devices, researchers have confirmed that certain stones vibrate at specific, measurable frequencies when stimulated. What makes this discovery even more startling is that some of these frequencies align closely with modern Western musical scales. One particularly strong resonance has been measured at 440 Hz, which corresponds to the standard tuning note known as concert A in modern music. This is the frequency to which orchestras around the world tune their instruments. To find it echoed in ancient stones is deeply unsettling, as it suggests either a remarkable coincidence or a deliberate design based on principles of sound and vibration. This has led to bold and sometimes controversial theories about the true purpose of Gunung Padang. Some researchers propose that the monument was designed as a massive musical instrument, a kind of stone orchestra built into the earth itself. Others go further, suggesting it may have functioned as a giant oscillator, tuned to resonate with the natural frequencies of the planet, including the Schumann resonances. These resonances are low-frequency electromagnetic waves that occur in the space between the Earth's surface and the ionosphere, often described as the planet's natural heartbeat. If Gunung Padang was indeed designed to interact with these frequencies, then its builders may have been exploring a profound connection between sound, vibration, energy, and consciousness. This idea finds echoes in many ancient traditions around the world, which emphasize the power of sound in rituals, healing, and spiritual practices. Chanting, drumming, singing bowls, and horns appear in cultures separated by vast distances and time periods, suggesting a shared understanding that sound can influence both the human mind and the physical environment. Some researchers believe the acoustics of Gunung Padang may have been used to induce altered states of consciousness. Standing within chambers or near resonating stones, participants in rituals may have experienced deep meditative states, visions, or a sense of connection with something greater than themselves. Sound waves can affect brain activity, heart rhythms, and emotional states, and modern science is only beginning to understand how powerful these effects can be. Other theories are even more radical. One of the most controversial ideas is that the builders of Gunung Padang may have used sound for practical purposes, such as moving massive stones. The concept of sonic levitation, where sound waves are used to counteract gravity and lift objects, may sound like science fiction, but it has roots in both modern experiments and ancient legends. Around the world, stories persist of sound being used to manipulate the physical world. Tibetan legends speak of monks who could lift heavy stones using chanting and horns, guiding the rocks into place as if they were weightless. The biblical story of the walls of Jericho describes fortifications collapsing at the sound of trumpets and shouting. In India, ancient texts describe mantras with the power to shape reality itself. While these stories are often dismissed as myths, the strange acoustics of Gunung Padang raise the unsettling possibility that they may preserve fragments of a forgotten science. If sound and vibration were indeed central to the function of the site, then the piezoelectric properties of the cement take on even greater significance. Vibrations caused by sound could generate electrical charges within the structure, creating a complex interplay between acoustics and energy. In this light, Gunung Padang begins to resemble not just a monument, but a machine, one designed to harness natural forces in ways we do not yet fully understand. Beyond the cement and the acoustics, there are other physical finds that add further layers of mystery, though they are often more contested and controversial. Some reports from the excavation describe the discovery of small metallic discs, initially interpreted as prehistoric coins. These objects have been tentatively dated to more than 5,000 years before the Common Era, which would place them far earlier than the world's first widely recognized forms of currency. If these dates are accurate, it would mean that some form of symbolic or economic system existed thousands of years earlier than previously believed. There are also stone tools that show traces of iron flecks, suggesting that the makers may have been experimenting with iron ores long before the official beginning of the Iron Age. According to conventional history, widespread iron use began only a few thousand years ago. Evidence of earlier experimentation challenges this timeline and hints at a gradual, uneven development of metallurgical knowledge that may have started far earlier than we currently acknowledge. Each of these finds on its own might be dismissed as an anomaly, a mistake, or a misinterpretation. Archaeology is full of debates, and extraordinary claims require extraordinary evidence. However, when these discoveries are considered together, a pattern begins to emerge. They point toward a culture that possessed a scientific toolkit far more advanced than expected for the Paleolithic era. This culture may not have left behind written records or monumental cities like those of later civilizations, but their knowledge appears to be encoded directly into the landscape. It is written in stone, sound, and chemistry rather than ink and parchment. The mountain itself becomes a kind of archive, preserving whispers of a lost science for those willing to listen. Gunung Padang, in this view, is not just an archaeological site. It is a message from a forgotten chapter of human history, one that challenges our assumptions about progress, intelligence, and the capabilities of our ancestors. It suggests that human knowledge may not follow a simple, linear path from ignorance to enlightenment. Instead, it may rise, fall, and rise again, with entire worlds of understanding lost to time and catastrophe. As researchers continue to study the physical evidence at Gunung Padang, they walk a fine line between skepticism and wonder. Scientific rigor demands caution, careful testing, and peer review. At the same time, true discovery often requires the courage to question deeply held beliefs. The stones of Gunung Padang do not offer easy answers, but they invite us to reconsider what we think we know about the deep past. In the end, the mystery of Gunung Padang is not just about dates and materials. It is about the nature of human ingenuity itself. Were our distant ancestors merely surviving, scraping by with simple tools and instincts? Or were they capable of profound insight, sophisticated experimentation, and a deep understanding of the forces that shape the world. The physical relics embedded in this ancient mountain suggest the latter possibility, hinting at a lost order of scientists and artisans whose legacy endures not in books, but in the very fabric of the earth. These are whispers carried through stone and vibration, waiting patiently for modern minds to recognize them. Whether future research will confirm or refute the boldest interpretations remains to be seen, but one thing is certain. Gunung Padang forces us to confront the unsettling idea that the past may be far stranger, richer, and more complex than we ever imagined. As we step back from the intricate details of Gunung Padang, its massive terraces, its enigmatic structures, and the fierce debates that have surrounded it for decades, and take a broader global view, the hill begins to take on a startling new significance. It no longer seems like a solitary oddity, a strange monument tucked away in the Indonesian highlands. Instead, it begins to appear as an essential link in a vast, unseen network of ancient mysteries that stretches across the world. Its story, as it turns out, is not isolated. It is connected to a host of other astonishing sites, each equally baffling, each whispering secrets that refuse to be neatly explained. These places are scattered across continents and oceans, and together they hint at a chapter of human history that has been all but erased from memory. It is as if we are discovering the faint traces of one ancient civilization, fragments left behind like echoes, shadows of a culture that has vanished yet still reaches out to us from the distant past. To begin this journey, let us travel eastward, across the vast expanse of the Pacific Ocean, to the southern tip of Japan. There, just off the coast of the small, unassuming island of Yonaguni, lies a remarkable and almost unfathomable structure submerged beneath the waves. This underwater monument, known to researchers as the Yonaguni Monument, was first brought to the world's attention in the year 1986 by a local diver. The discovery sparked a storm of excitement, skepticism, and passionate debate that continues to this day. At first glance, the Yonaguni Monument appears to be a natural formation, a collection of rocks shaped by the relentless forces of the sea. But on closer inspection, its true nature becomes impossible to ignore. The structure consists of enormous terraces, smooth flat surfaces, sharp angles, and what seem to be staircases and wide processional paths. Its symmetry, its sheer scale, and the precision of its geometric forms suggest a level of design that, if artificial, could only have been achieved by a sophisticated culture. Some geologists, such as Dr. Robert Schoch, have argued that the formations are entirely natural, sculpted over millennia by tectonic activity and powerful ocean currents. Yet others, including Professor Masaki Kimura of the University of the Ryukyus, insist that such perfect symmetry and deliberate design could not occur without human hands. If this is indeed a man-made monument, its construction would date back to the very end of the last ice age, roughly 10,000 years before the Common Era, when global sea levels were more than 100 meters lower than today. At that time, the structure would have stood on dry land, visible and accessible to those who built it. The similarities to Gunung Padang are striking. Both are massive, terrace-like pyramidal sites, both shrouded in mystery and both contested fiercely by scholars and skeptics alike over whether their origins are natural or the result of human ingenuity. From Japan, we journey westward to the arid plains of southeastern Turkey, to another site that has astonished archaeologists and rewritten the understanding of human history: Göbekli Tepe. Discovered in the 1990s, Göbekli Tepe is a monumental complex unlike anything previously imagined. Carved from massive limestone blocks, some weighing as much as 20 tons, the site is composed of circular enclosures supported by enormous T-shaped pillars. Many of these pillars are adorned with detailed carvings, depicting animals, abstract symbols, and motifs that remain mysterious even today. What makes Göbekli Tepe so extraordinary is its age. Radiocarbon dating has revealed that it was constructed around 11,000 years ago, predating not only writing and pottery but also agriculture itself. For generations, historians had assumed that people of this period were simple hunter-gatherers, incapable of organising labour on such a monumental scale. Yet here was concrete evidence of a society that was sophisticated, ritualistic, and capable of incredible feats of engineering during a time when human beings were thought to be just beginning to leave their mark on the world. Together, Gunung Padang, Yonaguni, and Göbekli Tepe challenge the linear, Eurocentric narrative of human history. They hint at the tantalizing possibility that a far older, more advanced civilization once existed, one that spanned oceans and continents. Scholars like Graham Hancock have suggested the theory of a lost civilization, a culture of remarkable knowledge and skill that flourished during the Ice Age. According to this theory, the heartland of this civilization was not somewhere in the Atlantic, as the legendary Atlantis might suggest, but in the now submerged continental shelf of Southeast Asia, a region geologists call Sundaland. During the Ice Age, when sea levels were much lower, Sundaland was a vast, fertile continent stretching across what are now Indonesia, Malaysia and the Philippines, linking them to mainland Asia. Gunung Padang, perched high on its volcanic slopes, may have been a sacred highland sanctuary within this lost world, a place of ritual, administration, or cultural memory. As the ice caps melted and the seas rose, this civilization would have been gradually submerged, its coastal cities drowned, its grand structures claimed by the ocean. Those who survived, carrying with them knowledge of engineering, astronomy, agriculture, and social organization, spread across the globe, leaving traces of their advanced culture in places like Göbekli Tepe and perhaps even influencing the earlier civilizations of the Americas. Viewed through this lens, the mysterious sites of the world are not isolated anomalies, but fragments of a once great civilization swallowed by the sea. Sundaland in this context becomes a historical reality that grounds the myths of lost continents in scientific plausibility. It links geology, archaeology, and climate change at the end of the last ice age into a coherent, if still speculative, narrative. Beyond science, these stories echo even older myths of lost lands and forgotten peoples. In the early 20th century, the explorer and writer James Churchward popularized the legend of the lost continent of Mu. According to Churchward, Mu was a vast, enlightened empire that once stretched across the Pacific Ocean. He claimed to have translated ancient tablets discovered in India and the Far East, which told of a people called the Naykal, who inhabited this paradise. This society, according to the tablets, was home to 64 million individuals, all living in a technologically advanced and spiritually enlightened culture. They supposedly mastered telepathy, astral travel, and even a mysterious form of energy that allowed them to defy gravity, enabling the construction of colossal cities and temples with astonishing ease. Churchward's account describes the catastrophic destruction of Mu some 50,000 years ago, when earthquakes, volcanic eruptions, and other cataclysmic events tore the continent apart, sending it beneath the waves. Only scattered islands such as Hawaii, Fiji, and Easter Island remained as faint remnants of its once mighty peaks. From a modern geological perspective, the idea of an entire continent sinking is impossible. Continents composed of lighter granitic rock float atop the denser basaltic mantle of the Earth and do not simply submerge. For this reason, mainstream scientists have dismissed Mu as fantasy. Yet the myth endures, and for good reason. It provides an elegant explanation for the distribution of enigmatic Pacific monuments, such as the Moai statues of Easter Island, the basalt city of Nan Madal in Micronesia, and the surprising similarities in myths and symbols found among cultures separated by thousands of miles of ocean. Here, science and myth begin to intertwine. While continents do not sink, vast regions of land can indeed be drowned by rising seas. Remarkably, the areas described by Churchward's Mu largely coincide with what geologists recognize as Sundaland. Could it be that the legend of a continent destroyed in a single cataclysmal event was an exaggerated cultural memory of the gradual flooding that claimed Sundaland? Perhaps even an astronomical event, a comet or asteroid striking the Earth, triggered earthquakes, firestorms, and mega tsunamis that are remembered in the flood myths of over 500 indigenous cultures worldwide. In this context, Gunung Padang becomes not just a collection of stones on a hill, but a surviving monument from a civilization wiped from memory, a highland sanctuary that escaped the rising waters and preserves a glimpse of a vanished world. The implications are profound. If Gunung Padang is indeed a remnant of an Ice Age civilization, it challenges the very foundations of how we understand human development. The global flood, often relegated to myth or scripture, might reflect a genuine historical event, a cataclysm that reset civilization, scattering survivors who carried only fragments of their advanced knowledge to rebuild the world anew. The hill, in other words, is a tangible bridge to a pre-Diluvian world, a world that may have existed in reality under names such as Mu or Atlantis, and whose memory persists through the myths that have travelled across millennia. Standing today on the slopes of Gunung Padang, one is struck by the power of this perspective. The hill is no longer merely a site of ancient stones. It becomes a mirror reflecting our own era, our anxieties, and our search for meaning. The questions it raises are not purely academic. They speak to the fragility of human societies, to the possibility that even highly advanced civilizations can rise and vanish under the weight of natural forces, leaving only scattered monuments and stories to testify to their existence. In an age of technological confidence and rapid progress, Gunung Padang is a humbling reminder that no civilization, however sophisticated, is immune to catastrophe. Rising seas, climate change, and celestial impacts, the very forces that may have ended the age of its builders, remain ever-present threats today. The story of a drowned Sunderland serves as a cautionary tale, a planetary warning written across time. For Indonesia, Gunung Padang carries additional significance. Beyond its archaeological importance, it has become a symbol of cultural identity, a testament to a shared past that is older and richer than previously acknowledged. In the year 2025, the government announced plans for a carefully staged restoration and further investigation of the site. These plans reflect a desire to reclaim and preserve a history that has been overlooked, if not forgotten, for centuries. Should Gunung Padang be confirmed as the oldest pyramid in the world, it would reposition Southeast Asia at the very heart of human civilization, challenging Eurocentric timelines and reshaping our understanding of the origins of complex societies. Yet this journey of discovery is not without hazards. The modern era, with its viral misinformation, AI-generated imagery, and social media exaggeration, threatens to blur the line between fact and fiction. Images of pristine pyramids, impossible claims of antiquity, and fantastical interpretations can distort the truth, creating confusion around sites that are already difficult to understand. Gunung Padang has become a test of our ability to discern reality from imagination, a lesson in the responsibilities that come with curiosity and the dissemination of knowledge. The saga of retracted papers and scientific controversy reminds us that history is not a static record of facts, but a living dialogue, constantly debated and revised. Ultimately, the true legacy of Gunung Padang lies not only in its stones or terraces, but in the questions it inspires. As restoration work continues and new discoveries emerge, the hill urges us to look deeper, to listen to the whispers of myth, to feel the vibrations of the earth, and to ponder a past far more complex and mysterious than conventional history allows. It calls on us to imagine the ingenuity of ancestors whose knowledge, though lost, still echoes through the monuments they left behind. In the quiet moments, when the sun sets over the slopes and the wind stirs the ancient stones, Gunung Padang is a place for reflection, a monument not only to a forgotten civilization, but to the enduring resilience, creativity, and curiosity of humanity itself.